1, 2, 1, 2. That's better. Hello, everyone. Is everyone ready? Is everyone ready?
Rob?
Dolezal. Dolezal. Yes. Where's my slides? You don't want to put me in? Can I come in? Can I get my slides? Hello, everyone. Thank you for being here. Sorry for the delay. So my name is Ahmed. I work for the New York Times in the engineering team, delivery engineering specifically. I focus on infrastructure, but I'm here today about the KCD. So let me tell you how we got this started. So back in Amsterdam, I was like in the expo area and I was asking people like, what's KCD? Because I didn't know it. That was last year, literally. Like I just never see it in New York. And then someone guided me through like, the way on how to do it and what to do next and how to can get this started. So I started a GitHub issue, and then from there, all of this happened, and I got like to join my colleagues here, Kelly, and I will mention everyone. But that's how we started the day. So I'm gonna walk you through the process why I thought about starting the day. So there's a quote here, the Golden Circle theory, about like people don't buy what you do, they buy why you do it. Sorry, I'm lagging, reading. So the why, that's the purpose for the event. We just need to have like a cloud native community, and this is the first cloud native community, Kubernetes Community Day event in New York. Then we are trying to create an experience. So like, stay up with us today because things will change. Like in a minute after the keynotes, we'll like kick everyone out, switch this to multiple tracks, and then you're gonna be here for like the rest of the day. After we're done, we're gonna have a happy hour. Then we're trying to build a good future for the cloud native community together. So that's the entire event. So this is us, all of us, most of the organizers for the event in KubeCon. What is the last one? Paris. OK. Yes, Europe. Too many, I forgot. And there are too many coming. I also forgot where they are being there. And that's everyone. Kelly, Julia, Cedric, Hemant, Valentina, Karen, Scott, Leslie, and Andres. If you are here, can you raise your hand? Can you just like clap for them? They did a great job for this event to be here. So let me walk you through the day. So we're gonna start with our keynotes. We have like amazing speakers here that we're gonna tell us many stories about many things. Then thank you for all of our sponsors that like made this event happen today. We have our session speakers. They're all here. You're going to find us. Like, we try to make it like fun, so everyone is in a blue shirt. Like, if you are not wearing your blue t-shirt, you didn't listen to what I said, so thank you. But like, it's okay. I know things happen, so it's fine. No problems. And the interesting part, after 5:30, like 5 is when the event ends. 5:30 is when the fun begins. So like, there's a first beast fun and there's another beast. So like, the other one is gonna be on the rooftop. You're already gonna see the rooftop at the expo, but there's a happy hour from 5:30 to 7:30. So this is some stats. So we have 250 attendees. We are sold out. Like literally, we are 255 by yesterday night. So we have 6 keynotes, 21 sessions, and 31 speakers. Thing part here is we're trying to make this experience better. So you probably need to download the mobile app, and I will tell you why. But if you don't have the mobile app, you should. If you are an organizer, don't do it, because you're not gonna win anything. If you are a volunteer, you're not gonna win anything. If you are if you are attendee sponsors, you probably wanna do it, and I will tell you why in a second. We'll bring it back. If you didn't catch it. So the app gives you like few features, but there's one at the end that I want to talk about. So like first, you can see all of the sessions. So schedule is going to be up on many screens, but like it's going to help you know when is the next session. You can also like get to the floor. This floor is easy. Like you can manage. This is the stage where I'm standing. Room 1, room 2, room 3. That's the conversion that's going to happen after. But like you just need to see the rooftop and know where's the sponsors. We have a networking section, so you can network with people and chat. There's like, you can find people like speakers, specifically, if you want to talk with them. Like it's a small event, so we can talk. We don't need the app. I love this photo, so if you want to take a photo, please. Like he's the first one who did it even before the event starts, so that's great. So that's the fun part. So I didn't list the prizes here, but we have a scavenger hunt through the app. So there are tasks in the app that you want to complete. So let me tell you the prizes. So we are like giving prizes to the first 5 people in the leaderboard inside the app. So we have a MacBook, we have a Fly DJI drone that like have something on it. We have a PlayStation, we have an Oculus Quest, and we have a Nintendo Switch. And that's gonna happen by the closing remarks. So like, you'll like do the math, 250, 5 prizes, your chances are good that you may win. So I'm not, but like your chances are better than mine. And that's about it. So let's do some magic for the Cloud Native today. Thank you. So now let's kick it off with the speakers. I would like to invite Taylor Delazelle to tell us about CNCF and stuff happening in the ecosystem.
Awesome, awesome. Wonderful. All right, we'll get, wonderful, wonderful, wonderful. All right, just booting up, getting buffered. All right, hey everybody, how's it going? Hope it's like, hi, howdy. Hopefully you're well caffeinated, you're ready to focus in on everything. If not, that's okay, these will be online later. So I'd like to talk to you a little bit today about scaling your cloud native adoption. I am going to be your tour guide. I'm going to show you what's off to the left, what's off to the right, and talk about who rescued who. Is it you rescuing your data centers, your workloads, all of your data? Most likely. This is a shout out to all of you who wake up at 3 in the morning and make sure that everything is running wonderfully. Before we dive into everything, though, I'd love to talk about what is cloud native. I've given this talk a couple times before, but I'm like, you know what? It's 2024. That's a pretty cool number, and it's even. So let's go back. Let's blow the dust off of this description. I went and I took a look at our CNCF Foundation GitHub repository, and lots of stuff changes in there. I think one of the coolest things about working in open source is the fact that not only can you go and access just about everything, take a look at old surveys, look at data, interact with all of these things and watch as it changes through time, but even the definition of cloud native has changed dramatically. You can see that this prior definition has this title of, the section heading was, Cloud Native Systems will have the following properties, which is quite prescriptive. And then it was hyper-focused on everything in containers. Didn't really focus on the networking stack, didn't focus on all these things that we know and that we interact with today. They also had a hyphen in microservices, which costs about 0.001 penny more in ink. So I'm glad that we got rid of that and went paperless too. When we take a look at the current cloud native definition, I've had a lot of people ask too, what makes cloud native? Taylor, I can run this on my Raspberry Pi at my house. I have this NAS storage system. Is this cloud native, even though it's within the boundaries of my own house? And the answer is yes, because when you're working with something that's cloud native, you're adopting practices and different methodologies. You're working with different interfaces that make up the entirety of this ecosystem. The goal of that is to have things that are scalable applications. That's what's creating this modern stack that everyone's using, this pluggability of everything. So we're working with containers and service meshes and all those things now, but we constantly are asking that question of what's next. Is it WebAssembly? Are we working with things like eBPF? Are there new standards and specifications that we can bind to and have that much more certainty as we navigate the ecosystem? Whoever you're using as a telemetry SaaS, for example, are they doing something that they're rolling that's proprietary, or are they abiding by all of the standards and specifications that we have within our ecosystem? What's nice about this new definition too, and was said a couple of years ago, is that this makes the ecosystem able to be scaled. We can continue to keep adding things to it and having these conversations. And then you can drive all of these changes with minimal toil. That's the goal. You can still deploy on Friday so long as you know what you're deploying. So I have some numbers on this screen, but I really want you to take a look at that last one with the 87,000 plus people within the cloud native community. That's you. That's here. That's you are part of that number. This is one of my most favorite slides to update to as time goes on, because we just see so many more projects come in, so many more contributors come in. A lot of people ask, is that a good thing? Do we want to see the CNCF take on this many more projects? And we have different levels for each of those too, right? Sandbox, incubating, graduated. You can kind of think of them like new potato chip flavors, and all of them shake out, and we get to see which ones we like, which ones we don't. And that's the whole nature of that ecosystem, is just taking a look at different things at their different levels of maturity and seeing what truly works and what doesn't. More of a history lesson. We haven't sold Netflix the rights yet, but when we take a look at cloud native history, we see all of these changes that have happened too, from drag and drop deploys all the way up to high-powered GitOps pipelines that we have today. Yeah, if you haven't moved to that, let's talk afterwards too. I actually have a couple things I have to get off Jenkins in my home lab. We have the other thing that we want to make sure is that we are supporting maintainers in these projects, right? It's not an easy job to go through and to triage all of these different projects, all of these different issues, focuses, et cetera. We want to make sure that people are happy as they're going about and helping the ecosystem. As they triage things, as they connect with people. We want to be there. We want to help you out when it comes to educating folks as well. And so we're happy with our numbers now, but they can always be higher, right? They're not 100%. We want to have those conversations, and that's why we host events and try to help out with the community in ways like this. So why would you want to adopt CNCF projects? It's judging by the attendance here today, looks like either you're really interested or you are working with projects like Kubernetes, Prometheus, OpenTelemetry, et cetera. And when we start to look at the reason why, that's when the strategies start to shine and they start to make sense. Many folks take a look at these projects and start using them because of that resource efficiency, right? It's not a guarantee that when you jump to the cloud, it's going to be hyper-optimized or cost-friendly or efficient, right? That takes time. You get it up and running, and then you start to refactor and work through that. But these cloud-native principles make that something that's a priority, something that's a little bit easier than if it were a waterfall deployment or something like that. When it comes to availability, multi-cloud and hybrid cloud, those are also huge opportunities that we're seeing many organizations leverage and take use of. There was, I think, a story recently where I believe it was a hedge fund that had their cloud presence shut down by a cloud provider, and they had set some up at other cloud providers. So even when the worst thing happens or a completely unexpected outage comes about, it's really important to have a multi-cloud strategy or just understand how to fail over your data centers or make use of that. You also get that higher development velocity as well, right? By using these projects, you can make changes in Git, push it up, use things like GitOps, and then get those things deployed to production, staging, wherever it needs to go. When we take a look at some of the real-world examples in organizations, I put many in a hat. I picked them out. Spotify is one of those. Spotify came on early within the CNCF, and they've been wonderful to listen to and stream while you're working on these outages and building these new platforms. They managed thousands of microservices, and they contributed the Backstage project, which has helped folks keep informed and then make different dashboards, share information with their teams, and just truly be helpful within this space. The next one is BlackRock. I learned recently about their Aladdin platform and just a lot of different tools. Being here in New York, I'm hearing a lot about the financial sector and kind of what's going on within the space. And that high velocity, that low latency, lots of different systems, things that aren't always up, a little bit more ephemeral and just very, very horizontal types of workloads. So that's been really interesting to hear. A lot of the real-time data, I think, is what's most interesting within this space, and just kind of hearing about what's going on and ways that we can support that better within the cloud-native ecosystem. All of these different strategies, approaches, and ways to adopt cloud-native for those use cases specifically. Last but not least, some people run from their problems. Strava makes running their problem and giving you solutions for that. So it's fun to be out on the road when I'm disconnecting and away from my keyboard, seeing what Strava does in terms of using tools like Kubernetes to really provide you a wonderful platform to be able to access your own personal data and show you ways that you can get better. They're a newer member of the foundation, and so it's been fun talking with them and hearing about what's going on. One thing that we've spun up last year, and we're just getting into, we just got past the crawl, now we're walking and kind of gearing up to run with this governing body within the CNCF. We have our governing board, we have our technical oversight committee, and our end user tab. End users are folks that are adopting these projects and using them within their organizations. They're not reselling these products or these different applications, architectures, et cetera. But they want to share that, right? So our tab is focused on sharing all of that knowledge with the entirety of the ecosystem, not just for end users, but showing what's possible, right? Having those conversations and by being your advocate within the end user space. We're so happy that we finally have a place for our ecosystem to bind to ask these questions, right? If something changes in Kubernetes, say we're switching a branch name or something like that, now we have a group that is consistent and stable in terms of where we can ask those questions. We're here to support your open source journey. So lots to talk about here, but it starts with consuming something, right? And just pulling it down, trying to make sense, kind of turning it over in your mind, and really getting familiar with what's going on. As you start to scale up and get to that leader stage, there's a lot that happens, right? It's how to get involved. All of you are doing that here. You're in the participant, contributor, and up stage. So I want to give you a hand on that front. Thank you for coming today. Really excited to see all of you. And I'm excited to talk with many of you here. If I don't catch you and you want to sync up afterwards too, I would love to have that conversation. We also have many different case studies. So I just covered 3 really quickly, but there are hours and hours and hours of content. Many different case studies for you to take a look at, some from Netflix, Spotify, and others. We're also doing we have one end user journey report, which is slightly the same thing, but it tells more the story of open source and how an organization uses that as their overall strategy. So we have one up from Spotify from 2019. That's several hundreds of internet years ago. So we have some that are going to be coming out from Adobe and Fidelity and other organizations. So I'm really excited to share those with you as those come out later this year. With that, thank you so much. Really excited to see all of you here today. Cheers.
Thank you, Taylor. That was great. And now Lucas Genzel from Loft will tell us about how to be a good neighbor to your Kubernetes tenants. Lucas.
Hey everyone, good to be here in this wonderful city. Probably a lot of you are local here, and odds are you don't live in a building like this. It's much more likely you live here. By the way, this is ChatGPT's attempt to put a Kubernetes logo on a building. Tried to hide that there. Didn't work out quite as well. I did have to double check, AI may be superior already, so want to make sure. Did CNCF change the logo? Not sure. Odds are that this is not the reality, and it more looks like this, to be honest. Especially if you're here in New York City. The New York Times talks about the everlasting scaffolding here. Not quite as ample parking, I guess, as in that ChatGPT-generated picture. Some ladders in the way, like a whole bunch of construction stuff. And sometimes if you're walking inside of one of these buildings, it doesn't get much better. We're seeing a story about the high-rise hell, New York City skyscraper that had an elevator breakdown for months. That's quite scary. This is like a 50-plus story building. So, good luck bringing up your groceries, or, even worse, like don't order somebody to bring up delivery unless you tip them like $200 or so, right? I don't even know how much time that adds to your commute if you have to, walk up and down 50-plus stairs. But I imagine it's not fun. Maybe good for your health, though. And then sometimes when you go into these buildings and look at the apartments, it doesn't get much better. This tiny apartment doesn't even have a sink in the kitchen. How does that work, right? It still runs for $2,500 on the market. That is insane, right? And to be honest, that picture is a really well-lit, nice-looking one, right? So I bet there's worse examples in the city. And if you're asking, landlords, tenants, sometimes the response that is actually quoted here, no one said it was ideal, right, is kind of describing in a state where it feels like people just don't care about the tenants. If we're administrating clusters, we have to care about the tenant that runs inside of the cluster. All of the examples before describe a tenant experience that's really awful. So let's make sure that when we spin up Kubernetes clusters, our tenants feel differently about the landlord, which may be you or your platform team, right, in your organization. In a lot of cases, companies create a ton of Kubernetes clusters. They create one per team, per customer, per environment. That has been a pretty predominant model in the past couple of years. But the problem with this is you have a lot of duplication, right? You're shoving all these things in each one of these clusters, and then you have to lock somebody down because you don't want them to touch this Istio or this OPA, right? You just can't make them cluster admin. The alternative to this, and not creating like hundreds or even thousands of clusters, is to essentially create multi-tenant clusters. But that actually typically makes the experience even worse, because now a tenant may just get access to a single namespace rather than multiple namespaces, or at least having a little bit more privileges. In 2021, we saw this challenge, and we started an open source project called vCluster to address this. What vCluster essentially allows you to do is create a multi-tenant Kubernetes cluster, then run your platform stack in there that you can provide as shared services to your tenants. But then instead of handing out namespaces directly and just giving people access to that EKS or GKE cluster, we give you a lightweight tool called vCluster that lets you spin up a container inside that namespace that acts as a virtual cluster. And now you can hand out this virtual cluster. And the cool thing is this virtual cluster only runs tenant workloads now. And it's a full-blown Kubernetes cluster. It's this like CNCF compliant cluster, right? It's a certified Kubernetes distro. That means the tenant can do whatever they want with these clusters without any restrictions. And they can use these shared services that you're providing to them. But if they need to roll their own cert manager, they can. And that's a great tenant experience. If multi-tenancy is something that you're interested in, I'm giving a session that goes obviously a little bit more into the technical details later today called Tenant Autonomy and Isolation in Multi-Tenant Kubernetes Clusters. It's at 12:20 right before lunch. And if you want to learn more, check out vcluster.com and our GitHub repository. Thank you.
Thank you, Lucas. I have seen the New York Times mentioned in the slides more than I have seen it anywhere else. And now I would love to welcome Julia Frost to the stage to tell us about the CNCF community and how you can boost your career.
Thank you. Hello, everyone. Can you hear me? Yeah, I'll shout. It's a pleasure to be here on stage and also off stage. I'm one of the organizers, and we've been putting this event together for over a year, like Ahmed said. And I just want to give a shout out to all the other organizers that have put a lot of work into it, into making this day possible. And also thank you everyone for being here. I'm sure we're going to have an amazing day. And when Ahmed asked me to give this talk, the keynote, I was thinking, should I give a more technical talk or not? And I saw, throughout the day, we're going to have amazing talks. We have an incredible lineup of speakers. And I decided to talk about the CNCF community. And why? Because the CNCF community is at the heart of everything. We wouldn't even have Kubernetes if it wasn't for the community. And also because the community has had a big impact in my life. And I want to share a little bit about that with all of you. So at first, the title was Boost Your Career with the CNCF Community. And then I crossed it. Let me see. Yeah, there should be actually a cross on career. And I decided to change the title to Boost Your Life with the CNCF Community, because it's more than just career. We have that work-life balance that we try to manage our personal life and our professional lives. And it's not easy, I know that. And the CNCF community can help with a lot of that. So I'm going to tell you a little bit about my story, my journey on how I got started in the community. But I'm just going to give you a summary. If you want the long version, you can watch my talk. I gave a talk at KubeCon in Chicago about my journey from being a non-technical person to becoming a CNCF ambassador. So I went to law school in Brazil. You might hear the accent. And then I studied business here in the US. And I worked in marketing for several years. And during the pandemic, I got laid off like a lot of people. And I started a coding bootcamp. And that's when everything started for me. I didn't know what Kubernetes was. I thought tech was just software engineering, and that's what I wanted to do. And I was very involved on Twitter. So tech Twitter, it was still a thing. Now it's X, and I haven't been on there a lot. But I met someone, and they gave me a ticket to go to KubeCon in Detroit. So that was a little over a year ago, I would say. Yeah, I started all of that in 2022. And I went to KubeCon. I didn't know, again, what Kubernetes was. I didn't know how, everything, the background from apps and infrastructure. I was totally blind to all of that. but someone sat with me at KubeCon, and they drew on a napkin the Kubernetes architecture, and they explained me everything, how it worked, and why it is so important. I was able to ask all my dumb questions, the questions that we're all embarrassed to ask. And things started to make sense a little bit, but still, it's overwhelming. I know a lot of you will agree with that, the whole CNCF landscape, and you go to a KubeCon and there are 10,000 people, so it was overwhelming, but I saw that there is a whole new world besides software engineering that I can be a part of. I want to learn more about it. So I decided I wanted to start contributing to open source. I joined the CNCF Slack channel, and I asked for help. Hey, how can I help? I'm new here. There is a channel just for that. And I started with mostly non-code contributions, so documentation, translation. There is a lot you can do if you're starting out. And even if you're already technical and you want to get your feet wet in the cloud native space, there is a lot you can do. We need your contributions. But then my first contribution, I messed up. I got an error. I couldn't, my PR wasn't going through. And I messaged again on the Slack channel, and someone stopped what they were doing to jump on a call with me and go through, like I shared my screen and go through everything, what I did wrong and what I had to do to get that working. I was able to submit the PR, merge it, and everything worked out from there. So small acts like that, of people wanting to help you. I also joined study groups for certifications, so the CKA and the CKAD, a lot of these certifications, they have study groups. I joined those. I had friends, because by then I made friends in the community that would review my talks before KubeCon, or we submitted talks together for KubeCon. Also review my blogs before I publish them. I had a lot of, small moments that you see, oh, these people really care. They want me to succeed. And that's the beauty about community. They want you to succeed. They want to lift you up. And one thing that I want to mention, and I want you to understand, is you can be part of the community and you don't have to contribute in any way, because we're not expecting you to do something in return. You can just join and lurk around, see what's going on. But after a while, you want to start contributing because you want to grow the community. You start feeling part of it. And I think you all made the first step of being here. Being at a CNCF event at this KCD is a big first step. And then you're going to meet other people, mingle. I encourage you to do that. And it's a great thing for your career because it's all about people. So I also had prepared some slides. So like you see, the CNCF is open, inclusive, collaborative, diverse. There are people without a computer science degree. There are people with 20 years of experience, and they all treat each other the same. There is no difference. And again, like I said, they all want you to succeed and help. So you just have to be willing to get into the community. And I encourage everyone to be a part of this community. So supportive, resourceful, engaged, a lot of events like this one. There are smaller events as well. And so how you can leverage the CNCF community to advance your career. There are a few things. This is not an extensive list. There are a lot more, and I would love to talk to you throughout the day about the community, about other things you can do, about non-code contributions or code contributions. Whatever you want will be here throughout the day. But things you can do, so network and collaborate with your peers, people that are here, get to meet them, and follow up, connect with them on LinkedIn. That's very helpful. join local meetups. So similar to these KCDs, there are local meetups everywhere. So probably where you're coming from, there is a local meetup as well. And they do these more frequent. Instead, the KCDs are once a year. Local meetups, they meet every month. And then you make a group of friends, that have the same interests as you, which is great. Skill development, again, studying, take CNCF courses. You can take their certifications, study with other people. A lot of the CNCF ambassadors, they have free courses as well. They do live streams on YouTube, on Twitch, and they just want you to learn more and everything for free. So I encourage you to check that out. The CNCF website has a lot of great content about community. They even have a tab that you can check out everything that they have for the community. Open source contributions is a big one. If you want to start, you can start small. You can check Contributor to see all the open issues in the within the CNCF projects. And if you really want to start, check out the documentation on contribute.cncf.io. But again, you're not forced to contribute in any way. You can just come and learn, and you'll see that after a while, you will want to add to the community as well. And access to knowledge and mentorship for those that are transitioning into tech or that are just graduated. They have mentorship programs teaching how to contribute to open source, and I think that's amazing. We need more of that. There are a lot of programs, mostly for software engineering, like I started, and not a lot for cloud native. And now we are starting to get together as a community and help those people that are first starting out get into the community as well and help them. There is a newsletter you can follow if you want to stay in the loop of everything that's happening. Career opportunities, internships. There are a lot of things part of the CNCF that you can take advantage of. And being part of the community will only help you, succeed and grow personally and professionally. Visibility and recognition, also being part of the community will give you credibility, so you can submit to give talks at events like this, the KCDs. You can talk at a local meetup as well if you want to start smaller. You can talk at a KubeCon, which is amazing. It's an incredible opportunity, and the CFP is still open, so you can submit something about what you do or a use case that you've worked on. And publishing content, a lot of times I believe when you're learning and sharing in public, that's more meaningful and you get to learn better what you're doing. So that's how I started, publishing blogs of what I was doing or recording videos. You can do that and it will help you as well. And finally, community support. Anything that you need, questions or technical questions, non-technical, you need some help, you're having a bad day, you can go on the Slack channel and just message there. And people are open, and I've had, like I said, I've made friends there, and I go out with them to bars here in New York, and I talk to them on the phone. So it's not just friends, acquaintances that I meet at conferences, but they really become your friends, and you have fun. While you're working, you're having fun, and then on your free time, you're also having fun. So that's the biggest takeaway that I want you to get is having fun while you're doing all that is thanks to the community. And again, if you have any questions, I'm here throughout the day. Some bullet points on if you want to get started in the community. You already took the first step by being here. Check the CNCF website, join their Slack, attend an event like this one, choose an open source project to contribute to, but you don't have to if you don't want to. and engage with the community. So come talk to us throughout the day, and I'm really happy to be here and to see all of you, and I'm excited to have conversations with you throughout the day. And I thank you, and I hope you have an amazing day. Bye.
Thank you. Thank you, Julia. That was from the community, by the community, to the community. That was a great way, like that how myself got into the community myself. And now let me welcome Fawad Khalik from Czech. He's gonna tell us about observability and what's gonna happen in the next decade. So.
Great to be here. It's November 25th, 2020, and I'm deep in my most beautiful dream at 5 a.m., and this is what happens. This is the sound of an Amazon pager. This is what wakes me up. This is what makes me feel like a catastrophe is impending and doom is on its way. And you know what? It did not just happen once. I got paged 91 times in the next 2 hours. Why? Because a customer made a deployment. It caused an outage. They were not able to recover from it. And this was not a one-off. Imagine you're making thousands of such changes every month, where changes are fundamentally uncertain, they're unsafe, you don't have a good way to identify what will break before it breaks. We have done an OK job with applications, where we have unit testing, integration testing, to deploy to prod to make sure they are safe. However, infrastructure is largely ignored. We have staging, but it's not sufficient. When we make changes to deployments, we don't know what's going to break before it breaks. So what do? We reactively fight repeated fires. If there is any error, failure, or disruption, or incident, or an outage, what do? We get our most experienced engineers who would go try to debug the issue. If they don't find the answer, they would work with the community. They would even engage the support from vendors or cloud providers, and eventually, they will find the fix. It will take 1 to 2 weeks. It's all reactive. And then another company would repeat the exact same mistake. And then another. And these learnings are lost in silos, and there's no way for them to avoid these known risks. Imagine a world where you could remediate these risks before they cause disruptions. Imagine if there was a system that could learn from these errors, failures, disruptions, converts them into signatures. Let's call them availability-based signatures, just like virus signatures. It could stream to all of the users, scan and detect in the infrastructure, and make sure they don't repeat the same mistake again. So you could learn from others' experiences and mistakes. You could prevent these errors, failure, disruptions, and you can save time and effort. Think of this system as a CVE for availability with a knowledge graph that captures all the relationships between the entities, the versions, the configurations, the components, the add-ons. That tantalizing possibility could be a reality. Today, we have our current observability and monitoring tools, like Datadog, Prometheus, Grafana. These tools are a must, but they are not enough. In the future, we will need to introduce a proactive prevention outer loop on top of these existing observability and monitoring tools to fortify them, to help you identify what can break before it breaks, to help you make changes in a safe manner. So that page I got, we don't have to get that page, especially on a problem that is already materialized somewhere else. You can use these proactive tools to prevent incidents from happening altogether. That's why we build Check. We build Check to make sure you can identify what breaks before it breaks, you can make changes in a safe manner, and you can speed up and de-risk your upgrades. With that, I have one very important message for you. That is, check yourself before you wreck yourself.
Check.
Thank you.
Thanks, Fawad. Thank you, Fawad. That was a great outro. So really excited. So the event is named Kubernetes Community Day. So now I would love to welcome to the stage Stephen Augustus to tell us how to release stable Kubernetes.
Thank you. Hello, hello. All right. Hey. I'm going to talk a little bit about Kubernetes. That's why we're here. We're at KCD, right? I'm Stephen Augustus, head of open source at Cisco. And I do a few things for the Kubernetes project. I'm part of the steering committee. I am one of the co-chairs for SIG Release, and I'm also one of the co-founders of the release engineering subproject and a senior release manager. If you want to find out more, whois.augie.dev. So who we are, SIG Release, if you don't know what SIGs are special interest groups within Kubernetes. The community has a set of governance groups, and there are committees, there are special interest groups, subprojects, working groups across Kubernetes. So the special interest group for release has a few chairs and technical leads. Myself, Sasha at Red Hat, Jeremy at Microsoft. Technical leads include Veronica, Carlos, and Adolfo at Offset, ChainGuard, and StackLock, respectively. And here's what we do. Kind of as the name implies, SIG Release is responsible for making sure that Kubernetes goes out on time and is of high quality. If you didn't know, fun fact, Kubernetes is the largest Golang-based open source project on the internet. I don't know what people are carrying around on USB sticks or handling internally, but on the internet, Kubernetes is the largest Golang-based one. So I think there's a common misconception with SIG Release and getting involved in SIG Release that the release team is SIG Release, and that is not true. SIG Release is composed of a set of subprojects. For Kubernetes, the definition of a subproject is basically that subprojects hold code, right? So they are containers that can hold code or hold some function within a special interest group, right? So the release team is merely one of those containers within SIG Release. The actual subprojects. So again, we've got the release team. It's very shiny. That's kind of what people view it as. And then you've got release engineering, and it's a bit more in the weeds. So I will say that I borrowed this deck from the team. They delivered a longer version of this talk at KubeCon in Paris. So if you want to check that one out, I will provide links later. So who we are now. Now that you know about the subprojects, we recently introduced subproject leads. Very excited because all of the people who are on this list have spent, I personally have spent 5+ years in the special interest group. The folks who are on this list as subproject leads, Grace, Kat, and Marco, have spent years on the release team at this point and years in release engineering efforts across Kubernetes. So very excited now that we have this subproject lead role to recognize their work officially. So hats off to them. Now, SIG Release in 2024. We decided to work on a roadmap, which is great and good, and every project should do this. What we basically wanted to do is kind of, again, as the SIG's name implies, make sure that we're releasing quality Kubernetes. We wanted to take a focus between 2023 and 2024 on making sure that Kubernetes was more robust, safe, fast, reliable, and flexible, right? And what do those mean? I kind of put them up on the screen. You can check out the roadmap if you want to. It's git.k.io. Fun fact, if you're ever looking for any repository within Kubernetes, if you git.k.io/repository name, it'll redirect to the correct one. So our roadmap is in the SIG release repository, and we're looking at making sure that releases are more robust. If you have ever worked with Kubernetes in the past and seen the release engineering tooling, it started off as a bash script, probably not super surprising here. Anybody use bash? Yeah, maybe one or two people, right? Yeah. So this is a bash script that was created by some of the original release engineers within Kubernetes. And that bash script grew to be very, very interesting. It was roughly 5,000 lines before I decided to destroy it. And that was 5,000 lines spread across multiple libraries. It was very, very interesting that we were not using a more robust programming language for releasing Kubernetes. Again, one of the largest Golang-based projects on the internet. So we're no longer doing that, but even still, moving to a Golang-based releaser, we were experiencing lots of infrastructure failures. So runs that would make certain assumptions on variables or state of the job at point in time. And we have been working across the last year and a half or so to make that a bit more robust, right? We want them to be fast. These jobs ran serially, and we would release multiple releases of Kubernetes at a time. During patch release cycles, that means we were releasing 3 to 4 Kubernetes releases that day, which meant you were waiting for each of them to complete. Very exciting time. Our release managers group within the release engineering subproject is kind of spread across. It's very much follow the sun. So we'd have folks that were in Asia Pacific or EMEA. They would kick off the release, and it would slowly rotate to US East and then US West, and we'd eventually release. We don't do that anymore. We can basically release a lot faster than we used to. Very exciting. We also want to make sure that moving forward, that any of our processes are flexible. Flexible in the sense that any new tool that we come up with should allow us to integrate with existing tooling, new tooling, and we should take those considerations to heart from the beginning of the process. So not let's cobble 50 more lines into this bash script and see where we get. It's let's make sure this is going to work for the next N years, right? So again, you can check out the roadmap, roadmap.md, and the SIG release repo. So let's talk about Kubernetes. The most recent release of Kubernetes, v130, is Kubernetes. That is Kat, one of the most recent subproject leads, her Cat Espresso. And the art is done by Kef Emoji. So the release team subproject, again, we've got release engineering and the release team. We try to improve the release team subproject every cycle. My internal feeling for the release team is that it should not exist. The release team is, I call affectionately, anyone who runs the release team lead is the chief cat herder for the Kubernetes project for that cycle. Now, a cycle will take roughly, it used to be quarterly, now it's roughly 4 months, right? Now, the release team is responsible for basically pinging across 30 plus SIGs within the project to make sure that they get their stuff done on time. And ultimately, that should not be a role that exists, right? And we've got a bunch of subteams within the release team. We've got the release lead. We've got an emeritus advisor who is someone who has experience being on the release team for a few years. We've got release signal. We've got docs, the release notes team, communications. So they work with the CNCF to make sure we're doing the webinars and we're doing the blog posts and all that fun stuff, and bug triage, right? Now, the release engineering subproject was spawned off of the release team. There used to be a branch manager and a patch manager. And the patch manager was responsible for carrying the Kubernetes releases till the end of that release. So that might have been a year and change for one person to be doing that. We don't do that anymore. We created an entire team of now 14 or so people responsible for that, and it works a lot better. So we recently, so again, my belief is that we want to delete as many roles from the release team as possible, and hopefully even maybe get rid of the release team eventually, right? But right now, the release team acts as a really interesting opportunity for people to get involved in the project. It is an opportunity that people flock to. And I have to say that it is one of the most difficult things to do in the project. So people that join the release team as their first entry points of the project, like, that is walking straight into the fire. So congrats to anyone who has joined Kubernetes by starting in the release team. It's not an easy thing to do. So we do recognize that the release team is an opportunity for contributions, and we don't want to entirely shut that down, but we do want to optimize the way that the release team works over time, right? So one of the ways that we've recently done that is we've combined the bug triage and the CI signal role into a release signal role. Lots of overlap between the two teams outside of watching for all of the issues and PRs that are floating through the Kubernetes repo and adjacent repos. They're also watching TestGrid. If you're familiar with TestGrid basically monitors all of the jobs that are running across the Kubernetes project, right? Jobs that are running in Prow, jobs that may be reporting status out from GitHub Actions, but that is one of the teams that watches for green signal across those jobs before we kick off a Kubernetes release. Documentation. Who likes documentation here? Anybody? Yeah, docs people. All right. So documentation is one of the most important things that you can do in an open source project, right? For the Kubernetes project, if you are releasing an enhancement, documentation is non-negotiable. It is a requirement for an enhancement, and we will block a release on documentation. So we introduced more deadlines and stuff. The docs freeze. So the docs freeze allows a bit more signal coming into the release docs subteam and SIG docs. We work in very close partnership with SIG docs, and most of that work happens at the tail end of the cycle. So if things are going badly with docs, there's a very strong possibility that we may have a delayed release. So over time, we were trying to improve that. We've noticed over the last 3 release cycles, we've either had interesting shenanigans happen with either docs or the comms. So we want to make sure that moving forward, everyone in the community is aware that we will actually block releases without having docs in place. So let's talk a little bit about the roadmap. You wanted to know what was happening in 2024 and why I'm here, how we're going to do a little to make Kubernetes releases more robust. We're going to be focusing on artifact validation. We want to make sure that debs and RPMs, which are for a lot of internal folks, the primary mechanism of consumption for Kubernetes releases, we want to make sure that those are more robust. We want to migrate away from a GCS bucket that was maintained by Google up until very recently. For those who are not familiar, I opened an issue maybe in 2017, 2018 about this bucket, and we only recently closed that issue. So the way that Kubernetes releases work would be we click a button, or we click a few different buttons, do some credential logins. Things happen within Google Cloud Platform, and eventually we get to a step where we would have to reach out to someone who worked at Google. We'd have to reach out to someone who worked at Google because they would have to sign the packages and then use a tool called Rapture to rapture those packages up into the package repository that was backed by GS Kubernetes-release. So that means that all Kubernetes releases at some point in time were dependent on having a Googler go, yes, that's cool, I will push these artifacts now. I'm not going to go into the details of how exactly those artifact pushes happen, but trust me, it was terrifying. And as the people who were responsible for that part of the project were shifted to different responsibilities internally, we lost our ability to. It was a huge bus factor, huge bus factor for the project. So that was one of our primary concerns. We want to move onto community-based infrastructure so that anyone can release Kubernetes. Anyone can sign the packages, build the packages, sign the packages, make them available to the community. So how did we do that? We got some help from our friends at OpenSUSE. So Open Build Service, if you have not heard of Open Build Service, or OBS, it is used by quite a few Linux distributions. They have spent some time learning how to properly handle security and do things like GPG keys, which we've been trying to figure out in the, I think, building a web of trust within an open source project is always fun and very easy to do. There's a reliability factor, knowing that we do not have to fully maintain the infrastructure and there is some offload into a well-trusted service. And also, they offered to sponsor the project and help us shift over to Open Build Service. So hats off to OpenSUSE for that. The Kubernetes project no longer uses that very scary bucket, and now uses Open Build Service on community-hosted infrastructure. So if you ever want to check that out, that is pkgs.kates.io. And I don't know if you can see that very well, but some very easy things to add into your your apt lists, or if you're trying to do that on trying to grab the key rings, here's how you do it. There's also a QR code. I'll leave that up for a hot second. Cool. All right. What else did we do recently? We also created a bunch of GitHub Actions. We realized that we were using GitHub Actions quite a bit for our release engineering projects, and we figured that it would be cool if we made them available to other people to use. So if you're concerned about provenance within your projects, generating SBOMs, checking your dependencies, publishing releases, publishing release notes, we use these tools, these GitHub workflows, for all of the projects within our release engineering subproject. And you're like, all the projects? What do you mean all the projects? All of the projects. So we have a few projects that we maintain within the release engineering team, and those are that may not even be the full list. Those are some of the projects that we maintain, and those are all using those GitHub Actions for release workflows, provenance, SBOM generation, etc. So what's coming soon for the security inclined folks? Sometimes we have security vulnerabilities within Kubernetes, and it's important to figure out how to properly communicate those in ways that are consumable to the public. So across our release notes, across VEX statements, across SBOMs within the various projects in the Kubernetes ecosystem, in partnership with the Security Response Committee. So I mentioned committees before. Our Security Response Committee is responsible for security response within the community. We have 3 committees: the Steering Committee, the Security Response Committee, and the Code of Conduct Committee. This team of folks is responsible for ensuring that we patch vulnerabilities and we communicate them safely and responsibly to the people who are consuming Kubernetes. Moving forward, we will continue to have those folks, but we're going to add some more fancy automation into the process, right? So between, again, release notes, VEX, SBOM, and integrations with OSV, we'll be able to do a bit better in reporting on status and having people be able to dial into some of those security feeds moving forward. But for us to be able to do that, we need you. We need you to make the magic happen, right? Julie had mentioned this is a project. These are projects where people can show up and do the work, get the credit, and have great conversations with people. SIG Release is one of those projects, and I would deeply encourage you to come hang out with us if you want to know more about SIG Release. We have weekly calls on Tuesdays. If you want to know more, we have Kubernetes/SIG-release is our repo on GitHub, and that has more information about all of our sub-projects, how to get in contact with us, including Slack, the main repository, release engineering sub-projects. So thank you.
Thank you, Stephen. Thank you, Steven. Now, like, he made the process with a team so fast that I have to upgrade my home Kubernetes from 118 to 130. So, like, just like, I still have more to go. So now, would love to. Now we talked about the release process. Let's talk about security and how to future-proof our Kubernetes. So we'll welcome to the stage Steven Gigor. Got the name wrong. I know it's just like. Hopefully you will get it right for me. From Palo Alto Networks, talk about Kubernetes security. Thank you, Steven.
Thanks, Ahmed. All right, yeah, I'm Steve Giguère. I work for Palo Alto Networks, and I wasn't actually supposed to be here right now. It was originally Michelle. Michelle's not here due to childbirthing situations, so I have jumped in at the last minute. I was given a title, and I thought, cool, I can talk about that. Next Gen Security Horizon, no idea what that means. I was given an abstract, which roughly came down to, oh, it's right there. Adoption, AI, future-proofing, mindset, collaboration, privacy, and then some marketing stuff. I thought, great, I'll just do my own thing, if that's cool. Whipped up some stuff, and the first thing, if you're thinking about future-proofing, my mind went to, I feel like I have to wander so people can see me. There we go, I'll do this. When did I first hear about Kubernetes? Oop, I'm gonna do this. Oh, how do I do that? Let's do that. How do I make it go big again? Thank you, magic people who do that. When was the first time I heard Kubernetes? So I first started on 1.10. So hands up if you were before 1.10, anyone? You are brave. Certainly from a security perspective, it was a little fast and loose back then. I first heard about it, I was working with a large supermarket manufacturer in the UK, supermarket company, kind of like a Walmart. And I went in and I was there to architect and make sure that they were doing all the right security things. And one day I went in and they said, Steve, we're going in a different direction. Java's out, and I was like, okay, cool, like that, like where we're going so far. It's all Go. I didn't realize it was a language when they said it. And it's gonna be containerized, and we're going straight into Kubernetes. I was like, sure, I know what you're talking about. What? I then left, realizing all my knowledge was now useless. And I invested heavily in understanding Kubernetes and what it was to be secure in Kubernetes, and that is a journey, to say the least. But we are getting there. I was very pleased in 2022. Jimmy Mesta, I don't know if you know him, he's pretty active in Kubernetes security, created the top 10 Kubernetes risks for OWASP, and I thought, yes, we have a list. That's what we need. Except if you look closely, and this is a direct screen capture from the OWASP site, right? All of this looks pretty good, and then there's just like, this one goes to 11, kind of link at the bottom. Other risks to consider. So it's not just a 10. Those of you in security know this. If you dive a little deeper into the OWASP Kubernetes security cheat sheet, one of the first quotes in there says, no one can track all potential attack vectors for your Kubernetes cluster. What a fantastic pep talk that was. This sheet, how big is a cheat sheet normally? A sheet. This is 28 pages, this cheat sheet. And my next question really is, how many people, I started to dive into this because I realized if this is the cheat sheet, what's the manual look like, right? Perhaps it's Andrew Martin's Hacking Kubernetes, which is not tiny. Maybe it's the CKS certification, which is a really good, hands up if you have a CKS. No, me, nobody. It's really hard to get that. You got to get the A before and then it's a lot of difficulty. Yeah, it's difficult. My point being, security is difficult. And we have a bit of a journey ahead of us. Kubernetes pretty much powers our world. When I first discovered it, people were tiptoeing into it. Maybe it wasn't necessarily in production, and hopefully it wasn't in production back then. There's an AI's influence. I had to say AI at some point, right? It's real, but it's totally uncertain. We love it, but we kind of hate it at the same time because we don't really know what it means in terms of security. Are we being attacked by it? Are we using it to defend ourselves? So a lot of security challenges await us. Which version of the slides is this? Sorry, sneak preview. So when I was when I heard about how do I future-proof Kubernetes, it came back to this. This is how we future-proof Kubernetes. It's by collaborating. It's by talking about Kubernetes. It's by talking about how it can be insecure. It's about getting involved with things like SIG security. It's about community. And this is why I thought, well, this is how we do it. You are the game changers. You are the future proofers. And I look forward to events like this, like KCD New York. I look for the next KubeCon, and I look for many of these to come. Shameless plug, if you'd like to learn more about security, I have a session in this room, I think, if this is 3, at 11, talking about terrible things you can do to attack open source projects using GitHub and GitHub Actions. I'm so sorry, it's going to be really bad. Thank you.
Thank you. Thank you, Stephen. So that was great. So that was a great start for the day, and I really want to get your thoughts on can you raise your hand up if you like the keynote so far? Okay, that's good. That's good. So we made something good today. So now this is the final board. I'm sorry, but we have when we're done with the keynote. So keep up playing the game. I just checked on the prizes, and there are people taking the game seriously. So I love that. Now, thank you all. We have to kick you out of here so you can enjoy your snack and then go to the rooftop and hang around there until we do some cloud native magic here, change the rooms, and then you come back at 11 o'clock. But thank you all.
Elevators and then R.
Yes. Thank you.
Good talk, good talk.
One, two, one, two, one, two, one, two. Check, check. You want a handheld or you want a loud? Loud, please. One, two, one, two. Actually, yeah. Just make sure you talk right into it.
1, 2, 1, 2.
I'll raise it from in there. You want a loud?
Hello, everyone. Hello, everyone. We will be waiting a few more minutes for more people to join. So if you want to grab some water or coffee.
wonder how many, there we go. How many KubeCons you've been to? But I remember the Barcelona one had just one giant escalator. And it was
Probably
like,
20 plus.
you just saw people going from other rooms.
Yeah,
to
you know,
lunch.
it's exciting to see how much of that
Constantly like, this is not
that
gonna go
learning, how much of those mistakes have taught us to be better with our
Yeah, I'm
system.
ready to go
Okay,
now.
so
And that's
Yeah,
part of the
okay.
motivation for
so like
for
all
this
of you,
for this talk. Oh, there. Is that on?
so I said we work on NVIDIA. Like all of you, we
Okay, I will try
NVIDIA,
not to
we
echo.
like to put
I can't
our
control that. I'm sorry.
GPUs
I have no power over AV.
to our data centers.
But that's okay.
Okay with the mics? There we go.
So
Okay.
I had a conversation
That's
with
okay, I'm trying
some
to-
folks
yeah, yeah,
probably
yeah.
about 4 or 5 weeks
Oh, I
ago,
lost the. I need to
and we were just talking about the reliability
away.
patterns,
Okay.
any of the failures that
This
they've
is
experienced, and how they
sponsored
recover from
session.
some of those
That's perfect.
incidents.
Is irrelevant
And
because
someone piped up and
Um,
said, "I've got
It's
a
like all of
bunch
you,
of
you,
loads
at
you
Austin
know,
Tech
everyone's
University
using
coming in
GPUs. So we
And
like to put
while
GPUs in
partially
our data
true,
centers and
reliability is
happens
not
already
just
with
about
it.
using a bunch of load
Put
balancers.
software on it
It's
and
a lot
see how they
more
run.
than
Is
that.
my open
find
source
different
project
things.
safe?
And so I'm here to
This
talk a
is
little
a
bit more
continuation of
about the
research.
So that's what we're going to talk
context
about today. Is actually
how you achieve reliability, things to think about,
terrible things you can do with
and
GitHub.
ways you can probably
and then
start
extending that
forming that
to
strategy
GitHub.
altogether.
There
My name is
was
Marina
the
Widjay.
cloud stuff
I
to
am
go
a
through.
solutions
Get
engineer
you
at a
already
company
know.
called Commodore.
Has-
Catch up.
We focus on
time.
Kubernetes
Here's the
operations,
has two types of
reliability, and
workloads.
troubleshooting.
So we've
I'm
got
also an organizer for a
security
conference
advocate.
called
I have
KubeHuddle
some
that
titles
is out in
and
Toronto
solo.
and
First
was
one,
first run in Edinburgh, Scotland.
I've been writing
So
code since
similar to a
embarrassingly
KCD,
age.
similar
Now,
vibes,
GeForce
very
Now.
I
Kubernetes
was heavily
oriented.
into
I am also a
Kubernetes and
CNCF
containers
and
for
SIVO
a long
Cloud
time.
ambassador.
So game
I
streaming, this
did
is
the hand raise. I was
Now,
only
way
CCAS.
described
idea
GeForce
of
Now
load balancing,
Yeah,
what
is,
is it? It's
it's
really about
Netflix for gaming.
And if you ever
having
find
a
yourself
pool of
in
resources
London, in
Good
England,
short
which
answer
is
that
actually
you
where I
get.
live.
share the load
that
at any
you could
given
take
time.
They made up their whole
game
DevSecOps
For
policy.
situations
could
where
stream.
scale,
You can open a
or
client,
for
you can open a
situations
browser,
where
you
you
can
might
stream a game.
have failures.
Essentially, what's
All right.
happening on the
So you
back end
have-
is you're connecting to a data
I
center.
know the answer to this
on the
because
back
all of
end,
you,
one of our data
right?
back end,
And I
and
also
there's
know
something of
this
a
is a whole
property
system
or
conference.
something
Perfect.
front end.
This is really an
load
APO
balances
So you can play your
those
game.
requests.
So essentially, like
When
you're
something
getting.
fails, well,
I'm going to talk a little bit about GitHub Actions. Hands up if you already know what they are, and I can blast through this and make up time.
Desk, we can actually
Let's be
take
real. This
access
is
to
just
something
not
similar.
Just
in
to double
cloud
down the
and
fact that they all
This
come
is
from the
not
marketplace.
all it is.
on this.
There's so much
and
more. There's
And so this is
we
what we
seem
do
to
in
implicitly
our
trust everything that
uh,
comes from this marketplace.
So this is a big workload that
and there
we.
is-
So I
support
popped
in
out
our
a
GPU
post
cloud.
on
different options
LinkedIn,
and wonderful things we can
and
do
I
with
just
primary
really
workload
talked
in
about the
this space.
context of
And
reliability
who would
and
possibly
what really
Second
think
one,
about
pretty new
compromising
experience
anything
for
one
in
of my
this
good
marketplace?
friends, Daniel Finneran, I'm
calling
sorry
it
if it's
Keep that in mind.
is,
All right, potential
NVIDIA
attack
Cloud
vectors.
Vectors.
he strongly believes
known
that load
methods that we
balancing is the
did
answer.
in this
And in a
research,
lot of
one
ways
is
it
load
actually
balancing,
is
another one is
because
NPM
it's just the
pulling out
context
another one is
by which
command
it's applied,
injection.
the
I'll show you
layer
a few
at which
examples
it's
of
applied,
I'm gonna
and the
describe
technology
repo
space
jacking
you're
first,
using to apply
because
that
it's
concept.
kind of complicated.
And it's also
for GitHub
funny
Actions
because
specifically.
he
So what is
invented
it?
a
So
technology called
this is
KubeVip,
very high
which
level
he
architectural.
hates
Just
the
so
load
you know,
balancer for
if you
Kubernetes
need more
analyze
for the
several
control plane
thousand
as well as if you're
repositories.
using it for
Technical as
service
well
and type load
reaches
balancers.
afterwards. I'll go through
Now,
all of
in
these
the
if you
research
I want
like.
to ask you a few
30,000
questions, and that's why I was
scans
high level. So
moving
we use
towards
Kubernetes
This is
six.
where
We
the
actually
research comes
started our journey.
presentation.
Repo jacking.
So
All right.
go scan that QR code. I promise
Say
it's
you've got
not
a
going to
GitHub
keep anyone
repository,
nefarious or funny.
and you
It's
move it. So
literally
you know, like
a
the
survey that I
view,
want you
so
all to
mine is your gig,
participate
and I have
because I want to know
namespace and the repository of the name. Those
we use
together
Kubernetes.
are
reliability or what
So
comes
think
up
about
when
If you
when
say
think
you
about
got bought,
one Windows
and
guest.
they
And
acquired
don't
you,
worry,
and then
that
your
QR
amazing
code
virtual
is
machine be
machines.
somewhere else.
And
So
Kuber, if you don't know,
that's
Kuber
fine.
is
You move
What does
to the
reliability mean
org,
to you?
a virtual
and
machine
You're
layer.
going to
GitHub will
be
happily
given the
Under-
option to
under the
just
hood, it's
throw
actually
in a
just
bunch
anyone
of
who's
words,
dependent on your
and
previous
primary layer
repository,
that
we're going to see a
workload
word cloud
cloning
pop up.
the previous one,
And
I'd
inside the
actually like
pod
to see
is
what that means.
libvirt
This is a
and
cool
QEMU,
feature.
right? All the tools that you get when you want to run.
you can even
Available
delete it,
trust.
and it still
Link
works.
hypervisor,
Now
and
then you
on
run into a
each of
problem
the
if you delete it.
a host we have
Because
KVM.
then I
So we
can
have this
slow
interaction
downtime.
where we
Steal
deliver
maintainability
KVM working
stays up.
together
GitHub
to
has
create
smoke
this
detectors
game
installed.
inside this
They were
game
retire the
session,
namespace
which is
entirely
what you've
if
established.
there's been more than
Client's
100
uptime,
clones.
graceful
Networking layer we
availability,
use so
stability,
Kubernetes, and
unwavering
we also use a bunch of other
So if
products,
it's
but
still
I'm
active, you're still
just
cloning
giving
it.
you the high level.
It will then say no one can ever have this
I've got
again.
another one right
The forward will be
afterwards.
forever.
A little bit
Mine's
about
not
it, so
done.
our
Hey,
cloud,
this
we've
is
got
that-
tons of data
that's a
centers.
good point
They're
of view,
located
right?
all over
I
the world.
think that
I mean,
liability
this is
translates
out of
the
date.
week
I mean,
before you
what
get rid of it.
happens to a business and how it cannot function.
The problem is that
So
if it's a
available
GitHub
and trust.
action repo,
But
you
we're
pull
doing
that
this
action,
all over the place.
Reliability
It's not a clone.
has ties
So you
to
can
a
imagine
building
like
facility
super
and
busy.
trust.
We've got
being
the
used,
service, we've got
forwarded
this
GitHub
large cloud,
function.
we've got
That's
a lot
something
of
to think
GPUs
about
that
for
is
the
there.
next time I deliver.
It's just
So,
an
what
asset.
are the
It's not.
problems? What are the
All right.
things
Like an
that we're
artifact.
facing?
So, what is
What are
reliability?
the challenges?
I've got a
So that's what
bunch
we're
of
going to talk through
different
today.
criteria that I
What are the
wanna
challenges
run
in the front of
through,
our
and
minds
like,
today? Like what are we
kind of give you
actually
stories,
through in our team?
things that I've encountered through the
And I can
past
we'll talk
that led me
through
to believe that there are better ways to
This is
achieve
actually what we
reliability.
face.
So a long
NPM
time
email
ago,
hijacking, if you
when I
don't
was
know what
that
that is,
sysadmin where
it is the
I was
it parses
supporting
the package block
clients
of a
and
JSON repository. This
users,
is how you script it.
imaging laptops and
So
servers and
you go get
deploying
that
Exchange and all
example,
that fun
this one
stuff.
actually works.
And I would still get
Goes right with
requests
the JQ,
from
and you will
developers
get
saying,
the
hey, I
email
need
of the
access
maintainer of
to
that project.
a Windows
then
operating system
go to see if
because
they
I want to
still
deploy
exist.
my .NET
That particular
application.
one, I actually
Great.
don't think it
Okay,
is.
let me call up my server
Buy
person
the mail
and
server, reset the
it'll
password,
take
and
probably
become
about
the
3
owner of the
months.
project and put whatever you want in there.
And then it shows up,
can just
and
script
it'll
this
take
and it
another
works
month
great.
before it's all imaged and patched and it's ready to go.
So,
But that
NPM does check
greatly
it,
affected developer
periodically.
velocity.
In order to
To see
One
if
of the
domains
challenges,
don't
though,
exist.
is
we
that
basically
you
they
bought
do,
this
they
massive
prevent it.
box that
But
only
if
one
you're
person
on
gets to
virtual
use.
machine in our data
And
center.
Constantly
so
checking, you can find
that
we
application they
leverage
built
our
maybe
streaming
consumes 10%.
magic.
Command
What about
injection,
the
you
other
might know
90%?
this one.
So it's
This is
got
an
wasted.
example
Different from
of
And that led
searching
to a
through
revolution
GitHub
of
for people who are using GitHub Bench.
We're
Let's
leveraging
hear
leverage
the
virtualization to
title.
pack as
NVIDIA
A
many
little bit
products
of
as we
regex
possibly
to see if the
can.
title
that
makes sense.
streams
Now,
the game.
why I bring up
Here's
right
the
sizing
amazing
or
standards
standards
to
in
the
your
user's
infrastructure
Unless I create
is because
and
if you
then it also shows
overwrite
the
size your
individual
hold on,
workload,
an issue title you can
if you
create.
oversubscribe them,
with
this is
games,
like-
users
if any of you
are
worked
like
in the
cars
storage
and
space, by the way, you might have
so,
oversubscribed your LUNs,
so we
right,
leverage this
for your
technology.
virtual
This
machines
is-
or your
this is
hardware,
one of the
and then you might
magic
run
we
into a
have,
situation
set
where
lots for game
you
streaming.
basically hit capacity for
So
storage
one of
because
the-
you've
other than
oversubscribed.
the
And that's an
streaming
incorrect
protocol
approach
is
of right sizing
So
because
one
now
of
that's going
the
to
challenges
lead
that we
to
have
some kind
is
of a
how
reliability
do we
issue.
connect
If
the
you run out of
user
storage,
to
there is
that
no
virtual
I/O.
machine that's running in a data center.
Yeah, if
So
you can figure out
the
'cause this is
consideration
this
here
an
is that
embedded video.
what is in
Especially for
place at
gamers,
the
they will
moment
tell
that
you
helps you right
if
size
they
your
see a frame
workloads
drop.
today
So
and gives you a better way
it's
to
important to us that
win at
we
Tetris.
provide the optimal quality for the end user. So it should seem
So
like
there's another
the
element
user's
around
playing the game on their
reliability, and
local
it's around
machine.
policies. It's not just about, hey, I can set
this is
up
one of the
a
main
firewall
primary,
policy that blocks traffic. It's
responsibilities
really
is
about
to
the
connect
guardrails
the data
that
center
you're
to the
missing.
user.
For example, if you're running Kubernetes at scale,
So the way
have
we
you
did
locked
this
down your
is
nodes
we
so that
introduced an
no one
NVIDIA
has root
scheduler.
access to be
So
able to jump
this sits
in,
very
spin up
close
workloads,
to
Embedded,
maybe
yeah.
cause
the
an anomalous
Kubernetes
service
cluster
attack?
that Ryan was talking about.
Right,
And,
that's one form of a guardrail
what
that
it
you
does is
probably
it
might
takes
want to implement. Maybe
a
you
bunch of
consider
different
using
choices.
something like the Talos operating
Some of it is
system,
come from
which is
comes from the
completely
user,
supremely
some
locked
of it
down and
comes
is just
from,
entirely focused on
or derived
Kubernetes.
from business
So there
rules
aren't any
that
other
our business unit came
daemons
up with,
or
and
binaries
some
running
of
on
it
that operating
is also
system.
input, but
the
also,
guardrails piece is interesting
the
because
state
I
of the
remember way
DC
back when
within the region,
I would install
the data
Windows
center where
operating
the
systems.
user closest
Remember
closest to.
when people would ask for admin access?
I'll go through them one by one.
Local admin access, what
when
does
the
that
user tries
actually
to play
mean?
game,
That means,
so
hey, I
focusing here
have
more
gotten
on the
access to
gaming
this
sort of,
server now, and I can install whatever the heck I want.
When the user
That's actually
tries
an
to play
anti-pattern
game,
today.
one of
We
the
don't
input
do
is the
that
user
anymore.
location.
We try to
So
limit
like I mentioned,
do that?
end users and
low
what their
latency
ability
is
to do
extremely,
for
extremely
infrastructure
important for
because we
gaming.
don't want them
Imagine you're
to
playing a
overrun
racing game
infrastructure.
on
We don't
Formula
want
1 or
them to
something.
over
You
consume
want to make sure
resources
that things move very fast.
and then break
so latency is
infrastructure so
extremely,
that
extremely
your other
important.
applications
So
suffer.
one thing we do is on
Service
top of
latency. This is an interesting one because this is dependent on
location-based
so many
routing
different
that we do, so we
factors.
direct you to the closest
When
data
you have
center.
latency that exists in
If
your
you play
network or your
GeForce Now,
environments,
you'll notice that
your systems tend to not respond
the user
quickly enough,
interface will
which
ask
tends
for
to
a
possibly affect
latency
application
test
performance,
between the
which
client
can lead to
and
reliability
the-
issues.
and
That wasn't a very
different
exciting
data
video
centers
anyway.
So how do you
restrict
address
so-
that?
For example,
Well,
what happens
we're here
there
in New
are
York,
so
saw the
many
tactics.
observability
Game.
systems
I
that
was
exist
taking the
that
environment
help
a few
you
data
understand
centers in New Jersey
to
telemetry,
use webhooks
monoliths,
outside.
the telemetry of your microservices,
Webhooks outside.
service-to-service
It just sits there and
interactions,
waits.
the service calls and how often
So
they
if I
occur.
pipe something via
And once you
curl
had that
out to
information,
webhooks outside,
you had this ability
whatever
to
that is
implement
shows up
some
on
level of
webhooks
QoS,
outside.
or quality of
So I pipe all the
service.
environment variables
And this is
out
not
to
just
webhooks
network quality of
outside.
service,
And I
like
set all the
the stuff
environment
where we would
variables on
implement
GitHub
DSCP and,
simply by creating
and
a
whatnot
issue.
for our
this
like, different
information,
queues. We're
because
talking
the
about
process has a shell.
understanding that workloads have different
So that was
classes
what
of
happens in that video. So that's like
CPU
step
and memory
one.
requirements and network
So I can skip
requirements.
that.
And they need to be classified accordingly so that they get the resources that they require when they're running.
One is free, you can play
And
for
then
free.
they don't consume resources when they
two other
don't need
ones
to,
have
but we can also track
special
that.
We can just go
We
with
can
that
also track things like when a service
priority,
fails,
so
do
you
we
get
have a
higher
circuit
priority to
breaker,
the
or do we have
GPU,
an ability to go to
compared
a
You have to do the
second
three,
or a copy
something like
three videos.
Oh wait, load
The
balance.
ultimate one is
So there are
you
ways
get
to
the
reduce
highest,
service
the best
latency
GPU
by
that we
also
have,
tuning,
the
right?
4080. today.
Now,
for
how
your
many of
games.
you have ever worked with a service mesh before?
This is one of the inputs. And
Great.
The third
this,
one is like
service
the
meshes
game. So not all
are
games
very
need the
much
latest
popular
GPU.
today,
So,
and they do help with that service latency reduction.
Fortnite, which is
because you're able to see the different services that do exist.
on the platform.
You're able to do some service
that
discovery, but you're
also
also
what kind of GPU
discerning
you're
patterns, communication patterns, request patterns.
So the last one is
request
the state of
failures,
the data center.
and then
so
you get
this
to
is
decide,
like,
hey, what's actually going on with this one service?
each data
might
center
do it
we
more
have,
time.
like in New York, we have a few.
So
they don't have all
a
the
long
types of
time
use cases
ago,
that NVIDIA offers.
when we had an
So
issue,
each data
like,
center
let's
could have
go back 50 years.
small subset.
I would have
of the
MRTG.
GPU.
Right, anyway.
I would have
Use
access
some of them
to
are-
I did this as
they go
a
back to,
logging
I
system,
believe,
where
where
log
I have
server.
two personas.
I would log
And
into
I
an
Tosca, we
offending
just
device,
add the issue.
and I would have all of these different
They go back
data
to,
sources
is it
that
based
I
on
have to comb
Ada
through to
or,
find out what an
Ampere
issue
or
addition to the
Turing?
repository.
That's the one I was looking for.
That's different today because
so
we
these types of
have
GPUs,
systems
they are
that
created- that
consolidate
are-
all of
are
these
constructed
extremely
with
powerful and
like
knowledgeable data
with different,
sources,
like it's
and
not
basically
the
allow
same.
us
We
to
don't have all the
either
GPUs
decide if we
it's
want
like
to create our own
So the
prompts to
state of the
decide
DC
what is
also
actually
means
going on or
what is
what we're
already
actually looking
taken.
for.
If
And
we
why
already
this is
have
important
users
is
playing,
if you're an SRE
we
or
need to keep
a
track
We all
of
understand
platform
the power
engineer,
how many of those virtual machines
imagine
are
if you were
used,
trying to reduce
how
your
many are
MTTR for a second,
being
your mean time to
brought up to be
repair.
used.
One of the
how
biggest
many of them are-
challenges
how many of them are not
is the
available.
tooling. You have so many tools to hop
Ryan's
into.
gonna talk
If you're
about
using Kubernetes, you
one of
might be
those
using
with
Lens.
that-
If you're
There we
using
go. All those weird characters were totally
service
fine.
mesh, you might be using Kiali
Our
to
NVIDIA
try and
schedules
see
all this
what's
information,
actually
and
happening.
I didn't
You might be
mention
using
here, but,
Wireshark or KubeShark.
when there's
These are all
contention,
different data
like
sources.
the
I have everything.
Which
time
creates
usage that we have.
fatigue as
That
well, because you
scheduler
also have
has
to
to
remember
track
all of these
also
logins.
what,
And so you
how
also have
many
to think
other
about the
users
cognitive
that are
load
also
that
requesting the game.
happens to a particular
with all
individual
their-
when they're trying to
their
figure out
similar features.
what's actually going
So it
wrong
has to
at a
react
given
to
time.
that.
That happened to me several
So
times
some of the
where
constraints that the scheduler works
the actual
with
resolution
is
of
the
a
GPU capacity we
problem
have is limited.
was
We don't
because
have
I had to
unlimited,
hop through a bunch of
capacity
systems and
everywhere.
it took me 3
And then
hours to
some
solve
of
the
it
problem. Where
is just
if
not
all
available,
of
like
this
I
was
mentioned.
consolidated
So
into
the
one
scheduler
platform,
has to
maybe
We'll eventually
I'd-
get done.
has to react, has to know how to
Other things
react.
we can do,
How
I can
many
do
of you
dependency
actually
if you know what that
sit
is, it's
there
dependency. It
and
looks
get
like another
scared when you have to
dependency and
click
help you download it.
the button
Doesn't work
for
that often.
Kubernetes upgrades?
Unless it's
So
pull
this is a
request or
visual
poison
of-
pipeline execution is great.
Right?
30,000
Hey,
CPUs.
the button's
If
there,
I
just click it,
submit-
right?
we know this if I
What's the
submit
worst
a
that could
workflow as
possibly
part of my
happen?
pull request,
A bunch of
here
CRs
trying to
break.
show, like,
there's
different
And then
only if I'm
Istio
not
stops
a previous
working,
contributor
or
was
Argo
not
CD
in that
stops
workflow.
working,
Even
or
before
some of
you
your
use
applications
scheduler
break.
sits,
if I'm not
And
so it's very
it
close to
becomes
how
very
many
challenging to
clusters
track
within
that as well
is
because
very
GitHub
frequently
workflows.
APIs
to know
deprecate. We
say,
know
do you want
mainly
to
the
prove and
state
run?
Kubernetes even tells
uh,
us when
state
they
of
release
scolds you
for not
what
clicking
APIs are
prove and run.
deprecating
And a lot
and
of
what
this
you
work
need to
has to
plan
happen
for
even
in the
before
next
you
iteration
want to run your
workflows.
and what you need to
Not
plan for
considering
and
that I
accommodate
just
for.
submitted a workflow.
So that's
we do a
like
lot of
one
work,
form of it. I mean, there's
just
other
to-
things to think
So
about as
you
as well.
ideally should have the second
that's
one.
not,
If you're using a
the
cloud
default
provider,
end
or
user
if you're
replace
managing your
So
own
what I do is I change
on-premises
the read
Before that
environment
happens,
for
there's a lot of
infrastructure,
work needs to
and
happen.
anything
you
all
probably
around.
have to be in
If
lockstep
your
with your
repository
provider
is
you can
to
see,
determine when
then
they
just
have
trying to
a
illustrate here two different
Maybe they
types
have
of
GitHub
use
repositories
cases,
they created
to
to
take
and then
down
all the
the
data sources that
entire
the
data center
scheduler
because
has.
All right.
And
they're
then,
redoing their
just
plumbing
The
or
GitHub
whatever
token
reason
has
that
pretty much
happens.
full
Just
rights to do
sits
everything.
within the data
But
center.
for
changed it in
situations
February
like
to
that, if you're
read
not
on.
in lockstep with them,
This is a good
that
thing.
leads to
This is
reliability
exactly
concerns
what
because you cannot be proactive when things
This is
fail.
an example of a pull
let's
request
say,
that proves
We
itself.
talk about the
user
disaster
wants to
recovery
Counter-Strike,
conversation for a
Counter-Strike,
second because
you can
way
do that.
back
The
in
only
the
thing you really
day,
can't
and
do
then
with a
it
GitHub
goes
token
to
people
the
had
DC at the
failures.
top.
is actually
If
merging
that
people
DC,
had
if
outages.
the
It's like one of the
scheduler
only
at
They
that-
immediately
the-
thought, hey,
the-
I've
the-
got
the
backups.
DC at the
Let me
top
take
This is
those
another
backups
example.
and then stand them up.
And we'll see if
a
I
virtual
can
add
machine in
another
that
video
data
or
center.
oh wait,
maybe
What does
if
it
I
do?
do
don't
that
have hardware to
permission,
do it. I gotta
So,
buy the
for
hardware
example,
now.
a user wants
Now
to
I've
play
got
a game that
on the
requires a
strategy.
Turing server,
Okay, so now they've got the
where
hardware,
I'm
it's all
exporting
warm, it's ready to
So
go.
the NVIDIA scheduler has
Now
to
they
have
want to
secrets to the same
restore
place.
their
like a
backups. Oh
same
wait, I didn't
environment
select
variable
my
command that
backup.
works.
data of what's happening in its data
Nothing
center,
is working.
but it also has
Great.
to have
Anyone recognize
an
this?
idea of what's
Okay,
happening
now we've entered
around
another
Weird
dimension
command
of
with lots of
replication.
carving my own
So
tracks.
what the
So
NVIDIA
we have a
scheduler
hot
does
That's
site,
a reverse
we have a
shell.
warm
if it
site.
hits
We're
that case where it
replicating our
cannot
data, and
find
we're synchronously doing so.
a
So
place
anytime
for
there's a
a
change
virtual machine for
in the
that
data, the
game,
deltas are
it will try to
transferred
forward
over.
it to the
Great.
to the neighboring
Oh,
data center.
shoot,
And this
I forgot
has
about
to
the network.
still
I
abide
forgot
by
about the
that
policies.
user
Forgot about the
location,
fact that if I move
feature
everything
of
over,
the request.
I've got to
So
re-IP everything.
we don't want to
And
send the user in
what that
Jersey to
what
go
that actually
to
turned into
Miami
is,
or-
okay,
or
if
San
I'm just
Jose or
spinning up
something
all
like
this
that.
capacity,
So
why don't I
still
just make
the
everything
latency
live
based on
and
that,
run at all times?
latency test that we
So
did at
that's
the
great.
beginning,
But
we
then
need
how
to
do you
make
handle
sure that the
failovers?
latency
How do you
still
handle load
acceptable.
balancing?
Sometimes the
And
users
this is
still
where
want to play
technologies like DNS
from a
and global load balancing come
data
into
center
the
just
mix.
because they know that
And we've
okay,
seen
the
how
virtual
those
machine is
technologies have
available maybe
advanced and been
Miami,
iterated upon
we just
to just
display
help
something. Are
with
you gonna
the
see
planning
degraded
of when we have to do
performance?
an upgrade.
But
you know, last
we don't
week
recommend it
I
if you wanna
was
go
I was
with
actually at the CNCF Toronto meetup.
So And then the follow-up question
we had
is,
Shopify
what happens
come
if
up
the
and
whole
present
neighborhood
a few
doesn't have
times.
access to the
So
GPUs?
how many of you know
If
the company
our
Shopify?
Kubernetes
Cool.
cluster does not have
So
any of
there was
that.
one
And this
particular
happens quite often,
presentation around
in the
how they
evenings when
handle
people come back from work and want to play
Kubernetes
games.
upgrades when they're running Kafka.
When this happens,
so they've got
is we
Kafka clusters
basically
all over the
queue
place, and when they have to do
queue
an
the
upgrade,
requests and
what they
what
end
that
up
means
having to
is
do
the
is they
queue
have
is
to
not
create
just a
the new
single queue,
cluster,
it's
point their
we're
storage targets,
sharded
which are
by
the PVCs
the
and
type
PVs to
of,
that new cluster,
user.
replicate all
I
the
mentioned,
data
like,
first,
some users
and then
have
have a
priority
small
because they're
window for
paying,
where they actually have the delta.
some
Do the
users have to
cutover
pay,
and then
what you
copy
do
a
is
the
game that
steal
requires a
deltas,
Dan
specific
Nooney's
which
account.
was
GPU,
fascinating but slow.
things like that. So the queue
Because
is
it
a
takes
little bit
15
kind of
hours
a
to do something like
big
that.
pipe.
So they
but,
came up with a better process.
fragmented
I can't
by
share the details
type
of that because I
workload,
actually can't remember
that the
the
scheduler
details.
needs to fulfill.
But they
So
shortened the
if that-
process
if
from
we
15
don't have
hours to
capacity at
45
all,
minutes.
Yeah, this is actually
And
then
that's
we
actually
put
pretty
users
shocking.
in
Good.
the queue.
All
So
right.
this
One
is
of
something
the
that
things that
we
they did was
try
they
to
realized
Remember, I
avoid
had two
for
they
personas?
leveraged a lot of
customers.
The white screen was the good guy,
principles
the
to
black
be
is
able to
the
achieve
the
that.
bad person.
But it's
Oops.
our
This
backup
is
plan.
a
So we
account
put
I have.
So here's
Loud Canadian.
here's an
into the
example
queue,
of a
and then
situation
this
of
also
reliability
signals to our
where
business unit
you
that
have
we
developers
we have more
working all
users
over
in
the
Amsterdam.
place and
We
building
want to
different tools. And
maybe
I'm sure some
expand
of you
our
have
data
seen this
center in
image.
Amsterdam.
But we
So I'm
have that
creating
one
a
little
suspicious
dependency,
workflow
and that
called
dependency is interesting
home.yaml.
because it could be anything. It could
I wouldn't
be
recommend
So to
being so
recap,
obvious.
the provider that we live
is
on. We're dependent
doing,
on
like,
that provider
feature
to
I'm gonna
matching
paste the
by
whole
type
thing in
of
there. You can
workload
see
and not be
requests,
under some
is
sort
made,
of
so its
like
main
government
responsibility is
regulation
to
all of a sudden. We
fulfill
might
the
be
request and
under
provide the
the
best
situation
GPU,
where one
resource
individual
for the end user.
developed
That
this
didn't run
IP
Now,
for how our
once we
application
have
functions.
this
But then they decided
schedule
that
that
they're going to
does
resign and they haven't
the
documented
feature
it.
matching, what we need
Now
to
what?
focus on
I'm
next
I'm
is
sure
one
we've
of
run
the
into
other
that.
challenges
That
we
actually
have
leads to
create
the
a
liability
is
concern of,
maximizing
you know,
the
what are we
our
doing to
capacity,
make
data
sure
center-
that our
data center
systems
capacity,
don't depend on individuals or
GFN
people
offers.
anymore?
So-
And that's where we've gone,
And
right?
send
Like
all that
YAML
in.
has really changed the game.
Why do we
hasn't it?
need
I
to do
think,
that? So
maybe?
number
I don't
one,
know.
GPUs are expensive.
Strategic
we have a limited
MTTR
amount of
reduction,
those.
So
right?
I'm
That's an
running
interesting one
Netcat.
because
And
it's
our
not
business
just
unit
about,
wants to make sure
hey,
You know what I mean?
I'm
When
going to
we're doing that,
strategically
of
reduce
the
my
GPU
mean
is
time to
time to
recovery.
recovery.
It's thinking
highest
about
waiting
all
for
what
somebody
I've
to
said
user.
and all what I'm
So,
going to say afterwards.
If we could see
Because
the
we also have
bottom
to
of
think
that,
about
If this is data that we're
reverse
looking
shell,
at every
think
you'll
day.
also
about,
see that
like
it
I
has a
mentioned,
32 or 33.
how long it's going to
the
take me
business
to
unit
provision
where it wants to
hardware,
expand.
and if I'm not provisioning
The
hardware, how
GeForce
long is it
Now,
going to
the
take me to
specifically
provision that
one,
EC2 instance or
the
Kubernetes
workload
cluster?
to set it up.
Okay, let me ask you. How long
takes
does
a
it
few
take you to
minutes.
spin up an
So
EKS cluster?
if you
Be
want to
honest.
play a game,
The
you
approval?
don't want to wait 3
And don't
minutes
cheat with
for
EKS
the machine to
CTL.
start
My
up,
good
for
friend of the GitHub
for
bot.
Kubernetes
Weeks,
to
right?
do its magic
Okay.
and
Is that
is
fair to
interesting.
your
everything.
business if they say
So
we want
Because
to
if you
deploy
came in,
this
that's the whole
solution,
point.
this
If
plays
it's
into
auto-approved,
we want to
you
run
only
it
that
one
lifetime
run, by
Mongo
the way,
at
it's
scale.
great
of a
adoption only has
GPU
one approval.
usage
No, fault.
utilization.
right?
Choose to.
And so we have to
And then
consider.
what we
I got
see
the
here,
GitHub
this is
token.
actually a
I think
snapshot
it's-
taken
could have had all sorts of
from
tokens
one
in there, right? I would've got
one
them
of
all.
our
And
data
so
that,
it's
two
not
ways to
just
get
about
that. One
sticking
like
to
that,
one
I forget
provider.
another by
Usually
dumping
these
it.
are- that's a
each
different
line
use.
is
download a memory dump.
showing the
Get the
type of
memory dump
the
from
GPU
your
reliability
usage.
concern, but if
So
they
you
spread
can see that we
other
have a
providers, maybe
sinusoidal
consider some of the smaller tier providers.
usage.
Now I'm on the runner.
Take some of this
I'm gonna make
like
my
every day,
on-premises
Shuffle
level.
code.
this just reflects that
Maybe
people
you
play
say I'm on
in the
runner.
evenings
This is
or
We have a
GitHub.
lot of flexibility. And
or
I think
at nighttime.
technologies like
And
Kubernetes
then
has
when
enabled that for us.
show you
when it
that
becomes like
the
3 a.m. or
PR
something
Getting
like
back
that,
into
the
service
usage
mesh
drops.
again.
So
So a long
this
time
begs the
ago,
question, how
when I
do
was
we
back
fill
in the
those gaps
when I was in
between
the
those peaks,
networking world,
to
one of the
maximize,
biggest concerns
I'm gonna
was
run
around what happens when a
few-
service fails. Does our application
really
stop
fast,
functioning?
you can
What
see what I'm
happens?
doing.
So,
Am I running out of time?
one thing we
I
do
thought
is
I
the
think I
scheduler that I talked about.
can't
One of its
remember, I've
other
lost track.
priorities
I made
is
this deck this
to
morning, by the way. anyway, I tend to do that.
to fulfill
Now,
the constraint
when you
that
think
the
about
setup
service
takes
failures for a
a few
second,
minutes.
one of
What we
the
do
cool
is
things about what Service Mesh really helped with in the Kubernetes space, and now even in outside the Kubernetes space, like in the bare metal and even
what
the
that
virtual machine
entails
space,
is
was that
the
it
scheduler
would
is
act
essentially making,
as a responder on
doing
behalf of the
interactions with the
service.
Kubernetes
The service
cluster
fails,
to create
well,
those
there's a
VMs
thing
and all
called
the
sidecar
resources that are
proxy
associated with
would
it.
go back and tell the rest of
This allows us
these
to
services,
achieve
hey,
that
I'm down,
just-in-time feature.
out, count me out for a
gaming.
bit
So
because
if
I
you're trying
still
to
need y'all to
game,
function, but when I'm ready,
all
again,
the
I'll
stuff
come
that
back
we talked
and play.
about the scheduler
And it was a
really
lot more
takes
than that
like a
because it was
second or
also the
two,
consideration
if
around
everything goes well.
if services weren't
and
smart
users are
enough
at the
to
menu
make calls to each
playing
other, we
after
could
like 6
indicate
minutes.
that
That's what I
for them.
remember
We could make that
seeing.
call for them through a service
So the
mesh.
pre-warming
If
That's
we
if you
wanted
don't
to
use signed
protect
commits,
the way
you can
services
change your
work,
identity to
resources
any email if it
the games
recognizes
are
it,
in
the
there,
student puts the
to
string.
install, they can be pulled.
Authentication and authorization.
And when the
mechanism.
user wants to request a game,
So
But
these are the
one
different
of the cool
methods
things
that
that
you can
Service
use.
Mesh
the
really
scheduler
does
connects
is
I even
retry.
got to the whole
VM
point of
with
the
Our
the
services
This is
naturally
the
don't
old version.
retry
This is pretty
themselves or
fun.
retry
This was
calls.
done at,
See,
So
so
Service
one
Mesh
of
can
the
be tuned
things
to
that,
that very
like I
extent.
mentioned,
API
the
gateways have been
scheduler
doing
makes
that for
API
us
I'm
for a
runner.
calls to the
long time.
Kubernetes
On the
cluster to
runner.
create
Just
those resources.
shorten that or
For the
make it
container
smaller
enthusiasts,
so
and
that
it
do you know
tracks
the
the
magic
state
Docker
of
command?
those resources
if
now,
you want
now
to
that you have all this data,
go straight
now
to
that you
root.
have
when
all
the
these
workload is, when the
considerations,
VM
it's
is
really
ready for
about a
streaming.
consolidation
we
platform, right? Bringing it all together,
the
tying it
resource
into a
state in
singular
Kubernetes
system.
plus the software
Now,
that we install
way
on
back
it,
when I was in my ops days, I
to
didn't
make sure that
have
it's
that.
ready for streaming.
I'd
So
log into a
things
bunch
like
of Cisco
downloading
routers,
the
ASAs, I'd hop
saves
into
like previous session in
some
the
cloud
game.
services,
And I'm
and
out.
Play
everything
the
would
game.
be all
We
in
don't want you to
parts.
start over from the
And
beginning.
today we
So
have
that
platforms
software
that
we
consolidate
track
through
that as well.
APIs,
So
through
Rory
the
McEwen,
tracking
I got that
also
from
various
tells us,
integrations through the fact that
the
operators can
times
live
it
in
takes
clusters
for,
and handles as
for
agents
this
and just
workload
report
setup to
on a
happen.
variety of
And
metrics
this
and
feeds
telemetry.
into a machine learning
So
pipeline
I've
that
got
we have
a couple more questions
that
for
helps us
you.
predict demand.
I just
So
I want
connects
to
the
know a
first
little bit
point.
about how many
So we
incidents
predict
y'all
the
have
demand
had.
based on the
And
data we
don't lie to
see,
me. I know you've had more than
in the
zero,
wild,
but if any of you say
and
zero, I
that
will
feeds
find
back
out and we'll have a
into
All right,
schedule.
what's
conversation.
like,
Okay, in the next few minutes,
We need to have a
actions that we're
conversation.
gonna get,
Whoever
so I can
said
start
that.
looking at whether you
X
have an
Fortnite
action
sessions or
and whether your
X
action has an
Abstract
action.
sessions or things like
And I
that.
can start thinking about those attacks.
This is
vectors
very
of those.
crucial for us.
And this is what we did.
And
We
we
created
keep
an
trying to
actions
keep an eye on it
dependency
very
tree
closely.
of those 7,000 repositories.
We'll just call
but
them
it's
generic
also
incidents for now.
supplemented
It doesn't
with,
matter, right?
With a goal of
Because
doing this.
because any incident,
another,
small or big, could lead
component
to
that
something
handles sudden
catastrophic
demand.
down the line, right? If not
Maybe
addressed quickly enough.
Fortnite does a patch of the game and new features come in, so more users.
10,000 starred.
Sometimes
No.
just
10 more
predicting
seconds.
based on
And because we're
historical
greedy,
data is not enough. So
30,000
we do
repos of
add
companies that have load
some like an adjustment.
We filled up with the den of GitHub Actions, hence 7,000.
Schedule
On the
just
repo,
to
check the
react
attack
to it. And
vectors.
that also feeds on that
Stole the
length,
tokens
the
and all
length
the
of
available
that
secrets.
queue that I mentioned.
Check
You
to
know,
see if
the
those
one
tokens
last thing
have
I'll say is
permissions.
DNS.
Like
DNS
the
has
permissions we're
been one of
talking
those
about.
very
yeah, so the
critical
prediction helps us
pieces. By the
scale
way,
our data
I
centers
decided not to
accordingly.
use
We found
the
one
generic
repo
haiku
that
literature
allows
that
the,
is out there on the
the
internet.
offbeat
I actually took a picture of that in
repositories.
Toronto.
Okay, so with the
and
offbeat
decided
times,
to
we
make
need
it. No,
to
this was like a
basically
last
use
minute thing.
that
Like, wait, I have that picture. I can pop that.
This is already been
Anyways,
disclosed, so it's not
DNS
new.
is always going to be a problem in a lot of ways in vulnerability issues. And we still see this today. Like, it's 2024, and we've still seen DNS-related issues.
So
Countless private
I also want to turn your attention to the Kubernetes era for a second.
one of the
Because
challenges
look, we're not just that, let's spin up a Kubernetes cluster, log in, deploy Nginx and hello world and be on our way. No,
just
we're
like
way
every
past
other
that.
piece of hardware,
We're past that
CPUs,
conversation of
How did
what
it really
version
work?
are we picking?
We can switch over.
We
we
actually
can
have multiple
download a new
versions that
driver,
exist
we can
today.
change the
We're
driver
using
on the
different
repository.
tools, different applications,
We got the GitHub
different
token.
systems
Right, we
that all
come across
integrate.
all the time.
And we changed this
So this
particular
has been a
action.
huge problem
And it
for
goes
us,
back to what I
something
said
that,
earlier.
like,
This
if you imagine at our
If
scale,
Kubernetes changes,
how are
and
we
version
going
goes
to
to
get a base
1.31,
driver failures that can
and
happen
then
all
your
the time? How do we get through
sub-applications
these
break.
things quickly? How do we move?
Right, and that's what
The
we all
V1
have to
reference.
get track of.
So we changed
So I've got one more
the
question for you, and I think
commit
we're
over
pretty much rolled.
a
So what we've
existing
actually done
commit.
is,
But
as
I
part of
want to
this,
know, like, how do you feel
we've
after an
worked
outage?
on,
Like,
so
how do
we
you
don't have to do
emotionally
anything
feel?
with API and Kubernetes.
What happens?
To be
to
our
actually help
going
us
through your
coordinate
mind?
things.
Essentially, we
So
created
just
a worm.
picture
Sad.
what I'm
And
talking
Once we
about is
affected the
that,
first one, way
what we
upstream,
here are
every
like
time this action's triggered,
all these
it
different
rewrote
cases that you come across. I think driver upgrade probably
things
being
all
the
the way down
most
the line.
common
That's
one
got
that you'll
to the
see
final.
when you're running your GPU. But all these things that you can come across when you're running.
I'm waiting
your
for the
Kubernetes,
resume
all
generating
these things that
event
you wanna
one.
do. And in
So,
our situation
you said 10
specifically,
minutes.
we're running.
I have a
these-
demo where it shows
these,
that.
These game sessions,
And
right? These
instead, I'll
are
tell you the
stateful
company
workloads.
Learn
and
in June,
This
and
is
you'll
all
see
good.
can't just
Guess
say
what?
delete
how that
this.
works.
When
and-
incidents
you
occur,
get
we
the
learn
idea
from
is
them,
that
and we get
one-
better. We
all
got
those
better.
different
we need
methods
to
we had,
know
the
how to
GitHub
work
token
around
is
it.
highly
users
vulnerable.
We know how to
for
prevent
at
them
least
from
the
ever
fact that
we need to give them their
occurring
time to play the game.
permissions
So
are
essentially,
not
the way I would
managed set to
describe
read for older repos.
this API
There are
is
platforms that
They had
exist
branch
that
prediction
allow us
rules
to
that were not
consolidate
set
all this
correctly.
beautiful
you
They did not use
different
protected
pieces of
tags.
information, all these
that
systems.
They did not
are
limit
not
the
Argo,
network
all the way to
usage because in order for this to
Kubernetes.
work, we had to
That
reach
system
out
So this kind of
shows up.
grab our
situation
program
is
that would then
no longer
run the
talking
commit
about
using
here,
the token
And it's
and change
beautiful
the
because
text. So
guess what?
we
These
were
are the
also
systems
reaching
we
out
get
mess
access
around
to
with today.
things
Like,
that
how many of you are
driver
using
fails.
Slack today?
How do
They
I
were
get
not
the
pinning the
machine
actions using a hash.
free?
They were using a
Everyone
version.
99% of your users.
So this is what we've done. We actually
then none of these attacks will work.
something we're gonna.
But the reality is,
this is
with
kind of
these
a summary of what it
systems, they
does.
tell us information. They act as
We
like
detect a
chatbots
GPU
for us
failure.
sometimes and
We
tell us when
plan for
something goes
maintenance,
wrong.
and then we
And
close it.
For us
down.
today,
believe it or not,
it's
So if you
common.
imagine, like I said,
So
we have a lease center.
I am not
GPUs.
going to show you a
You
demo
can't
because
just
I'm out
kill
of
the
time. Actually, I
pod
never planned to show you a
and
demo.
on
But I will
Another
say,
way to do this,
Commodore is sitting
technically
on
have
the
to wait.
rooftop
Just
somewhere.
wait
Go
for a
check
little
them out. Go have a
Open
conversation
Waiting is
about
expensive.
Foundation,
Kubernetes
rate
and your reliability
efficient
challenges.
in our waiting.
Scorecard.
And there's a lot of things.
And if you have any
actually that you can do
questions
efficient.
as
So if
well
you go
about
get scorecard
anything
running on
in my
your
past
laptop,
around
if
what
you
I've
know
been
what
doing
we
around
do
disaster
a lot of
recovery,
things
If you're
like
really clever, you can
pre-warm
script it
sessions
so you can get it to
put VMs
check
on
the repos
hosts
in your
that
dependencies.
are actually not running a game.
Done.
They're just
Squeezed
sitting
it
there
in.
waiting for someone to attach. So we have all these opportunities to be really efficient with waiting. And so that's actually what we've done. We've built a finite state machine that allows us to coordinate
Good.
maintenance.
That's it. Thanks.
Have a bunch of sources plug into this so that we can learn all these things about our workload going on the node so that we can be really efficient. Okay, this node is ready for maintenance because it's got driver failure and there's no workloads on it. So let's go ahead and do maintenance, and we coordinate this at large scale across our entire fleet. This is what it's called. We call it Notify Maintenance. Like I said, it's something NVIDIA is going to open source at some point this summer. And the whole goal of this is it's just an agnostic finite state machine to coordinate maintenance. Essentially, we call it just a maintenance API. Just like if you were doing maintenance anyway in Kubernetes on your stateful workloads, you would go through all the same steps where you need to coordinate node, you need to plant maintenance, you need to wait until it's drained in whatever form that means, and then you need to go and do work on it, and then you need to return it back to the cluster. So all these things are the same thing that you do, and that's all we've done is we've built an API extension to do that, and it works really well for us given that given our constraints. And then finally, future work. I'll start with the last one. So like I said, something we want to open source actually because we want it to be I'm wrapping up. So we want to open source. We want this to be like an API in Kubernetes that people can use for managing their GPU clouds, GPU clusters. When you do maintenance, now everyone's got GPUs in their clouds. They're running their AI workloads. They're running all sorts of different things, and you may or may not have cloud native applications. And so this kind of thing is what we want to leverage as a solution and for NVIDIA to provide for people that are doing maintenance in Kubernetes. And then
for the first point, it's just the system is a little bit complex today. The business rules are evolving. We're still manually configuring a little bit our data centers, so we're looking into doing it in autopilot going forward.
Okay, and that's our talk. Thank you very much.
Thank you.
Come find us afterwards if you have questions, and reach out to us if you see us in the hallway. We'll happy to answer any questions. Thank you.
Thanks so much. And coming up next, there's going to be 5 minutes in between this session right now and the next. In future sessions, there'll be 10 minutes in between. We just got a little bit of a late start, so wanted to give some extra time. So thanks very much.
Which session is next?
Thank you, everybody.
The next session in this room is about, it's also a networking session, right? It's net cluster. The various options for multi-cluster by someone from Red Hat. Yeah, it's going to be comparing projects. Just want to make sure to get his name pronounced. And then it's going to be. Sorry. Thanks. We'll clean this up. Thank you.
ahead.
Hello, everyone. We will be waiting just for a few minutes. They are trying to put the slides on that monitor. And also, if you want to grab some water or coffee in the meantime, feel free to do so.
So is mine going to show up on the back, or do I have to stand here to see my own slides? How did you do yours? All right. All right, we're good. All right. Hi, my name is. Oh, are you doing the intros or am I? I'll do it. I am Matt Butcher. I'm the CEO of Fermion Technologies. You asked this morning, Steve, who was there before 1.10? We were really, really early. We were in 1.1. That was when we started working on Kubernetes. We were at a little startup called Deus,
that's
and
an
we were
earlier
building
draft,
a PaaS that was intended to compete with Heroku, who was sort of the dominant PaaS provider at the time. And we kind of the secret sauce that we were going to bring to this was we were going to use containers to do this, but we didn't have a really good container orchestration system, so we were auditing all of these different container orchestrators like CoreOS Fleet and Apache Mesos and Docker Swarm, and along comes this impossible to pronounce orchestration system out of Kubernetes, out of Google, called Kubernetes, and we started playing with it, and I just really liked it. It really resonated well with the way that I had thought we should be able to do things. I had worked at Google previously and seen Borg and was like, oh, this is like all the magic of Borg, but actually simple. And simple it was at the time. It has since gotten less simple. So we kind of re-platformed onto Kubernetes. And then in the process of this, started looking at different gaps in the Kubernetes ecosystem. One of them was there was no package
half the
manager.
presentation already.
And so we started building a package manager. The original name of this package manager was Kate's Place, and it was all coffee shop themed. And we did this as a hackathon project.
It needs to go to the slides, not the PDF.
So we won the hackathon, the internal hackathon. I've got a $75 gift certificate for Amazon that the three of us who worked on it split.
That's why we
I
just
spent
did
my
the
$25 on coffee.
We just
And the
did
day after
put the
we
video in the
did
slides,
this, the CTO and CEO called me and said, and whenever the CTO and CEO both call you, it's like, I'm getting fired.
Even the video is embedded in the slides. Everything is in the
Kate's
slides now.
Place
It just plays.
We liked the idea. We think that maybe there is room in Kubernetes for a package manager. You should do it. You know, we'll free up your time, give you a team, go build this thing. There's just one caveat: you cannot have a coffee shop named. Coffee shop themed package manager. So Jack, my co-creator, and I sat there going through a nautical dictionary, reading words back and forth until we landed on Helm.
Get started, right?
And that was where we came up with the name Helm and charts and all of that. Was sitting there with a nautical dictionary, neither of us knowing anything at all about boats or ships. But from that, Deus Labs got acquired by Microsoft.
Everyone. Well, welcome to our session today. So Fabad Khalid will be talking today about how to eliminate availability, risk, and perform timely updates.
Just start doing projects.
All yours.
Thank you.
Build new interesting open source tools, push them out into the open, go to customers, go to other people inside of Azure, learn what their problems are.
If you guys use Amazon EKS, you don't like something in EKS, you can blame me for that.
14 of us.
I was one of the early engineers there, helped with
Can I just play out of my laptop?
And that's where saw the
Or it will not get
failures, which were
but it won't get recorded.
and frequent across customers where they had no way to learn from each other.
There's a lot of fun.
If there was one
Along the way,
disruption,
anytime you're doing that kind of open-ended R&D work, you start
Is this the PDF or is this the slides?
things that customers or internal Azure teams were telling us were problems, and we try and solve them, and we couldn't figure out.
I don't know whether the video will come.
Today I'll be talking about how to
Do they have permissions? Do they have the permission for the video? Because I gave it. I gave the permission to the slides and the video.
across any of the
If
layers.
if the permission for the slides isn't working, then the video permission may
How to
also
catch
not
them before
work.
they happen.
Several different interesting conversations we had with
Okay.
And how to
So
make
can
sure
we-
your upgrades are performed in a safe manner, and so you don't have to
Okay,
spend.
I'm
They're
just
kind of
going
two
back to
big points.
So let's
that I
get
hope
started.
When you walk out,
Let's start with
you
the pain
remember these
points.
two. This
Right
is
now,
one,
we've got
and the other one,
questions from
keep it here
cloud
open for it,
providers.
would be the component
Let's say
model.
Amazon EKS, GKE, AKS.
But this is how how
or you may be running
parsing out
on-prem.
the world.
You may have your homegrown distribution.
So pre-cloud,
you take those clusters, you bolt some add-ons on top of those clusters. These
bare
could
metal
be
machine
from open source,
had a
these
single
could be from
instance
vendors,
of the
or
cloud.
providers. An add-on is something like
Sorry for the confusion. The slides might be slightly older, but close enough. You can see the WIP over there, work in progress. But
cluster is running
hopefully this is more than 90%
20 to 40
accurate.
add-ons.
Good enough.
And on top
So
of that,
thanks
you
for
have
coming. We're
applications
talking
that
about
are
Kubernetes and
getting
Cloud
called from your
Native.
customers who are your
And the original subtitle was, are we there
Now,
yet?
when
Like,
virtual machines
what is the
came
status
around,
of this field?
that equation changed
And
a
I
little
added
bit.
another tab to make
And
it explicitly
upstart
talking
online
about
bookstores
patterns of
figured out
multi-cluster
that they
networking,
could sell
projects,
their
and some
spare
suggestions.
The risk is
capacity
anytime you make a change in
and
any of
turn it
these
into
layers,
kind of a
you don't
secondary
know
line
what's
of
going to
business.
be
It's now probably their main line of business.
Quick
right?
reminder
So
of the problem
AWS
statement.
what
really
kind of
had
change is
defined
risky, what
solution
kind of
patterns,
impact
idea that we can build a
some
system
relevant projects and APIs, some recommendations, and if you have time,
what do you do? What do you do to ensure safety?
From
this
kernel
is
and
a little
drivers
bit about
all the way
myself.
up
I'm at
to
Red Hat,
you
and
know,
I've been
studying
doing
what changes
cloud
are being made.
networking
Now,
stuff for a
virtual
while.
machines
You
are
would read
powerful,
release
right?
notes.
They're going to be
You would,
around
you know,
probably a couple
reproduce,
of decades.
So let's go over the talk, and
similar
we are
concepts
talking
and
about
so
the
much done.
networking
Most of
aspects
Azure
of multi-cluster.
services,
There's
Amazon
also
services,
many
all
other
experts in every
non-networking
single
aspects.
vertical. Someone is an
We won't be
expert
getting into
in
that
networking,
today.
someone is an expert in
Even the
ingress,
networking
and
aspects are
SQL, and
huge,
service
so
mesh and other
hopefully we'll have
technologies.
enough time to cover at
Even
least some
after
of
that,
that.
their
as a
knowledge is
small
limited
development
to
team
what
at a
they know.
startup,
But these are
build a
just
system where we
for
were
The third is
information,
pain point is
some
the
links
world is all
on
about reactive
other
response and
aspects of
reactive
multi-cluster
troubleshooting.
that you
Anytime
would
something
probably
fails,
want to think
suddenly
about
your
my
favorite
three
in
division
addition to
development team was
networking.
like
responsible
Datadog,
for everything
CCS,
from
Grafana,
kernel-level
you see what
vulnerabilities up
fails,
to
then you look at
making
logs,
sure
you figure out what the
was
root
running.
cause
That was
is.
just
Once you
too
find the
much
root
for a
cause,
small team to
you
take
would
on. So when
incident
we first
management
got a
to
taste
make
of
sure
Docker
that problem
containers,
does
we're
not
going, oh,
happen
this is
again.
great.
So,
Right? Instead of needing the whole
However, there's
operating
no way
system
for you
from
to
kernel
so
drivers up
and
to
eliminate
systems,
known
kind of a
risks.
pie-shaped wedge of
Known
an
risks
guessing
which
that
have been
most
materialized
of
by
you are
someone
familiar
else.
with the use case, so
That's where
why
check
would we
comes
do
in.
multi-cluster at all?
There's one more angle
Just
around
reminder.
upgrades.
So
As
if
if
you're
you are an
thinking
mostly
ATS
around
customer, if
heavyweight
you're running an
class,
older
having
version of
HA for
CTS,
your
right,
applications,
right,
disaster recovery, you can't have
cloud
all your
providers,
applications
then
in
containers
one
really come in
cluster,
as sort of the
impose
one
a
location.
500% or
they're very,
600%
You make
very
real
surcharge
clusters, but at
if you
some
run a
point you go to have
process,
multiple
which could be
clusters, and you
around
probably don't want to have
hours or
them
days
separately.
or
So
months or even like
multi-cluster is
check comes in on that as
inevitable
well.
at
Containers are
some
just
point.
fantastic.
Let's look at the world today. This is something
So
you
here
run
we are
back
in
here.
Azure.
sort of a similar slide
And
here.
you also get
And
improved
today,
performance. You can go to
organizations
serve
are
clients from different
reactively
geographies.
fighting
And
with
one of
the
the
data
other
gravity and
aspects
compliance. There's
of
plenty of
you
reasons
would
why
have,
you have to do
like an
multi-cluster.
instrument packet loss,
So
for
you might as
example.
well plan
You would
for
have
it.
the most experienced
You know,
engineers
what you say
who
is
try
like,
to
which
debug
I'm
it.
guessing
If
many
you
of
don't
you
find the
know
answer, they
are.
will look at GitHub
And
issues.
I was like,
release notes,
buckle
and
But
in
work with the
what
community.
we've tried to
Also
show is
engage
that
vendors
there
and
are
partners.
these cost-benefit
And,
trade-offs.
eventually
There's
we'll find the
a
answers.
suite of solutions,
And
and
then
some of
another
them
company
are
treats the exact
probably
same
more
problem.
complex than
Like,
what you
makes the
might
exact
need.
same mistake.
So
And
you've
then
got to
another.
sort of understand
And
what
then
is the
another. So
level
these
of
learnings are getting lost in
functionality
silos.
to complexity
There's no way
trade-off
for them
that's
to avoid
suitable
these known
for
risks.
my organization.
And that's where
that's
tech
really
comes
the
in.
key
Two
thing.
is
Try to
that
help
we
with
learned
that.
about these errors,
Okay.
failures, disruptions, which have happened
running on
already,
its
or
own.
got triggered somewhere
Um,
else. We learned the root cause.
So let's start with the architecture patterns. There's a lot of patterns here.
Just like virus signatures.
This is just to illustrate.
Think of it like a
I've
CD
got
for
some
availability. We stream
slides
to
with a
all
lot
of
of
our
content. I won't be
customers.
going to all of those,
We
but hopefully
scan and
we'll get
detect
a
the
chance to look through
infrastructure,
this data.
and we give them
I'll touch on some of the points from
safely
these slides.
mitigate and remediate
So,
these risks.
you know, there's
So now you
north-south
can learn from
networking across
others,
clusters.
but
We're not talking
operational
about
experience
north-south
is an
into a
operational
single
mistake.
cluster, things like
You can
Ingress
prevent error failure
and Noteport.
disruptions.
We're talking
You can
about
save time
cross
and money.
clusters.
The other work
When you're
there's
performing the
east-west
upgrades, which is one of the
cross-cluster
most, you know,
networking.
time-consuming,
More than
error-prone,
just
painful, and
internal
risky operations,
cluster
especially on the
service
lower
first
layers of the
networking.
infrastructure, which is your cluster.
There's all these other
networking.
things, single mesh, multi-mesh,
There are
federated
hidden
meshes,
dependencies.
and various
across layers,
operational
across
aspects.
components.
So
It's a
these are the
very
patterns
labor-intensive
that you
work
would
to identify what those
take into
dependencies
consideration
are,
when
because they
deciding
keep
on the right set
changing
of solutions.
on every change that you
Right?
make.
And we
It
talk
requires
about some
months
of
and
these
months of research
for
work.
today's
For
talk.
30 seconds.
And if you
get
don't
the machine
make that
started up,
change,
do
you are
the
at
So,
risk of
response
downtime.
back,
To
and
give
it's
a
on that
visual
last
feel for
If
some of
you're in
these
a financial sector,
well, they queued up.
it's not okay for you to
patterns
run end
we
of
just
cloud
talked
or end of
about.
life versions.
Pre-running
So here's
virtual
sort of
machines.
a
You may have
conceptual
security
picture of
patches. So for those reasons,
generic
you have to
multi-cluster
keep running
topology,
versions. You get new features to make sure you have the security.
where there's
Holding
4
down,
clusters,
check, and
which
plops another one
Makes
on the back.
your upgrade process a
back here.
breeze.
We knew
just
We
keep
help
running.
you
research that
get
developers
ahead of
loved
these
writing serverless
hefty
functions
surcharges,
easy
fix these availability
different,
risks.
different projects have different views on whether you
How do we do it?
where we could solve some problems.
connect,
There
you're
were a
combining
couple areas
clusters
like
or
that.
you're
Upgrade
combining a
process,
virtual
okay,
mesh
so what are we looking
topology
for?
on top top
that
of
we're
you
looking
have
for
clusters that
a
aren't
cluster,
actually
let's say you have 50 to 100 clusters,
coupled
you
together.
sit side by side machines and
For now, just look
you
at it
would have an
logically. So
upgrade
there's
cycle.
this
Let's say you're getting
north-south
from 125 to
multi-cluster,
126,
which in this
126
case
to 127.
is shown using this
you
English
would read
gateway,
range
which is
this.
actually
You look
a
at your
multi-cluster
infrastructure as
gateway,
code,
right? So that is the
you would figure
pattern
out what
we need to
which
think
one of
about
the resources are relevant to
when
you.
deciding the
You would come up with some sort of an
north-south
upgrade plan internally,
networking
like a
solution.
Google Doc or Word doc. Then you would look at what's changing in the layers on top.
Then there is this thing
would
about
repeat the
single
same
network
process
versus
for each of the
multi-network. So in
clusters.
this case, clusters 1 and 2.
Figure out what is relevant to
We'll
you,
come
what
back to that
features
in
and
just a
components
minute.
you're
But
using.
before that, I wanted
And
to show
eventually,
you why we
you would
got a lot
have
of
a
enthusiasm
huge
about
upgrade
serverless
plan, which is a document.
and what we mean by serverless.
You will give it to someone internally.
So
You will
this is
say,
a complete
go and
serverless application
simulate
that
this
does Hello
upgrade
World
internally
spin,
on
which
some
is
sort of
our
a dev
WebAssembly
staging environment.
serverless framework. So
They will do a
it's about
meticulous
6
job
lines of
on
code.
doing that. And after that,
all it
you will
does
figure
is
out who are the
expose a particular
stakeholders.
function
There
that
are
gets called,
application
handed a
teams
request,
who have a
all good.
misconfigured project,
So,
or they are using a remote API, or there's an application.
Yeah, so there's the north-south pattern. So in this case, you've got 4 clusters.
You will see
And
all
you've
of
got the
those
north-south pattern,
you
which you
send
need to think about.
notifications, get
Then
the
there
work,
is
get the work
the
done, and finally
east-west
you will
pattern.
perform the cluster upgrades.
The
and
network,
upgrades
so
to
here
the
cluster
cloud.
1 and cluster 2 are on the
Check
same network,
cuts
which
down
essentially means
the
that the
research work
ports
and the
can
pre-work by
directly
8
reach
times.
each other between cluster
We
1
have
and
a
cluster
knowledge
2.
graph which
They
generates
are
this
all,
cluster.
they have unique
In terms of
IPs, there's
notification
routing.
approvals, it's the same process.
So you don't need to NAT, you
And
don't
then
need
even
any
in the
gateways to go
in
between
terms
1
of
and
the
2.
upgrade execution,
But you do need a
cut
gateway
down by
to go
2x.
between
Now,
cluster
if
1
you
and 2
pre-flight checks,
pods
post-flight
or
checks,
cluster
upgrade
3 and 4
steps.
pods. That's
So
why you have that
end-to-end,
thing called an
this
east-west
process
gateway over there.
becomes 3x faster.
So that's
that becomes
significantly
because you can achieve
needed when you
very
have
high
these,
levels
How do we do it?
when you want to connect
and
pods
consequently
across
get rid
these
of that
networks.
80%
So that's the
offers
pattern
you
about the single
Kubernetes
network
availability
versus multi-network.
platform
And you need to
helps
decide,
you,
or you might have a
identify
constraint on how you
what
want
breaks
to
before it
do
breaks.
single network versus
We help
multi-network.
you speed up and de-risk upgrades, saving you time and money. It's delivered as SaaS. It works with any Kubernetes cluster,
So orders of
as
magnitude
long as you are upstream API compliant.
Okay.
We work with
So
multi-cloud,
why
multi-prem, AWS, GCP, Azure.
Many of you probably, when you hear
all of those are
WebAssembly,
supported.
immediately go the route I
we
did
cover
the
hundreds
first
of
time we
add-ons
threw
from
this
open
idea out
source
here.
vendors and cloud providers.
That's a browser technology.
If you don't cover an
It was
add-on,
built
you
for
can
a very
request it.
specific
It'll be
purpose,
added within 48
which
hours.
was
That's our
to
SLA.
run code other than
And we
JavaScript
integrate with your
inside of
existing
your web
workflows.
browser.
No, there's
We
There's
offer
a story that I
three
thought when I was at
product modules.
Microsoft
I'll talk about
was a
each of
fable,
them.
but turns
So
out
while we are waiting
The
for
first
that,
one is
I
risk
mean,
ledger, the
Microsoft
second is
Office
artifact
have-
register,
how many
the
of
third
you
is
might have
multi-provider.
deployed a
And our technology is
multi-cluster
called collective
Kubernetes or even non-Kubernetes
There was a scene
networking solution?
that as well.
that had been around since the
So it looks like
mid-1980s.
about
Let's look at the risk ledger.
30-odd%
Risk
of you,
ledger
which
helps
is a
you
good number,
eliminate
which is great.
risk
And I think that
before they cause
mainly
it.
speaks to the maturity of
Where,
Kubernetes because
let's
by
say you're
now
running
you've
a
had
defect.
so
There's a
many clusters
dependency
deployed, you have to
which is
do
present in one of the
something with
components. Let's say you're running
multi-cluster
externally
Kubernetes. You can't avoid it.
And if you're
And
using
hopefully the rest of you are either actively thinking
there's a
about
memory
it or
we will tell you the memory
just
file
wanting to
is.
know when you should be
There's an
going in
intermittent
there.
packet loss
And I think
using,
the key point here is that
Nginx
there's a
Object
lot of
Controller,
projects and
and
it's
that
always
happens
going to
6 times a
be
month
a
because
cost-benefit
you are
trade-off.
on
You
a
don't
certain
want to
configuration. We call them trigger conditions.
get overly
We will tell you
complex
it's a known risk.
unnecessarily
You should fix it before it
You
causes
want to
problems
kind
on your side,
of
especially if you are
take it
sensitive
step
to
by
context.
step and we'll illustrate some of the possible
These are
phases
all
you
different categories of risk that we report in the risk
when
ledger.
Figma wrote
It
the
could be
even
a
have
deprecated
those video
API or
videos
deprecated
you
registry
run in the
or
browser.
a
They
removed
run C++,
feature.
compile
There
it
could be
to
something
WebAssembly,
incompatible.
JavaScript.
You may have
So those were kind
misconfigured
of the
something.
core
You may
use
have a
cases for the
defect.
browser version of it.
So with
But if
check,
you're
you
gonna
can
run in the
prioritize your
browser,
top business
go now?
critical
You have
risk
to check
with
off a
clear and
few
actionable
All right,
insights.
let's keep going.
Continuously
So these are the
hard. Number
patterns we
one,
talked about, right? So this is
actually
sort of the
you can
logical
learn
view
from
of the
others,
patterns.
avoid repeating
Now,
no
let's talk about a couple of those. So let's
second
start with
module is
north-south.
artifact
So the
register,
security
where we
sandbox
catalog
on
all
WebAssembly
the
actually
containers,
stringent
all the
analysis
clusters,
that not
add-ons.
So
only
here
did
we've
it
got
Right
two
now,
clusters,
the
clusters
browser
1 and
some
2.
sort of
and the underlying
spreadsheet,
And the
operating
pattern
where,
we're
or a
doing
wiki
here
page,
is
or
we're going to
JavaScript page where you
duplicate,
have
fully
all the
duplicate the
add-ons
applications between the
what
pieces.
version is running.
So
Someone has
all
to
the traffic
go and
here
manually maintain
across
is it
the
end of life,
is
it
going to be
incompatible?
north-south in and out of the
connected to your
clusters. There is
system already
nothing
built.
going
For the
sideways
browser,
between one
the
cluster and
anything. You
another.
can't say this page
across
is
your
not
entire
available on
And
Mac
so
OS, or this page is
in this
cannot run on
pattern,
ARM.
you've got to think
So
about
they needed
the
a binary
different
format
ways
that
you
was
can
built
do
across
this north-south
architecture
load balancing
and
across clusters.
operating
Right?
systems.
Again, we're not talking
and the
about
final module
And that's,
is
upgrade well beyond. Sometimes we talk about like
so
Docker.
one
With
popular way to
Copilot,
do that
we
is
help
using
you
DNS based
delete and speed up
and there's
upgrades.
about
This
4
has
patterns we
actually
verified, and
runs
they're
from,
listed in the next
and
slide.
our daily
But let's talk about this one right here.
The way we deliver upgrade Copilot
So here
is that
the application is completely duplicated.
So WebAssembly was built
What
with
you
cross
see here is
platform and
one
cross
of the
architecture,
sections
but
is
it was
called
also built for a fast startup time.
stages,
and
and every
it's
stage has
completely
one or more
duplicated
steps. So
in
you
all
see
the
over there, we
areas.
perform the pre-work for you
And
when it comes to
waiting
this.
for
We
sites
can
to
use
load
one
on
of
the internet.
to tell you
a few
what is
different
changing.
projects
In
out
fact,
there.
a lot of
what is your
research
current
suggests
situation,
that
what's
the
the
time window
window,
is somewhere
what's your
between 10
current
milliseconds
what's
and
the
100
current
milliseconds.
One of the
to
scenes
give
is
you
called
a
something
refresh
that
check, to give you
is called
install checks.
KGV.
Google
and
will
there's a few
step
others.
continue when you cross
So
100
let's
works
use
as a
this
co-pilot
KGV
where
style approach
someone would
for
have to
this
do all
So
the
this is
speed
kind of a
trees
well-known
where they
thing.
have
So
to
are these
compile
controllers,
and
kind of a
GC1 and
surprise to me as a
generative
backend
backend
man,
where you can go add your own custom
but so
steps,
WebAssembly was
which are
built to be very,
you can
very
delegate to someone
communicating with an external
who is
DNS provider,
not able to do it
native
before,
perhaps
because
from
typically
XC3,
right now it requires
and
judgment
having
from
their
the most
particular
experienced engineer on the
variety
team.
so that
URL
it can
getting
speed up
delegated.
Right now you can
So
generate
that
object
the
files,
GC1
and this is
get it
actually
approved,
by far
delegate to
become
someone,
the
they can go and
short
execute it,
native
and
DNS
check it will become
resolvers
that
for
system of
those
record.
domains.
So WebAssembly was
So what happens is that when the client goes to DNS mode and I want to go to
then,
your lower
it
operating
actually
loads
gets
and improve productivity.
served by either
You can
GC1
plan
or
ahead,
Team
GC2,
at Google, and
which
at
are
the time,
actually
the
communicating
Edge
within
team at
themselves.
Microsoft.
And they are
Critical
deciding
Analytics,
based on the
another
health of the
Now
microservice.
you must be
then
wondering
let's
how
work
does
on
this
this
all
together.
work?
Okay,
Let's work
we're
on
going
this
to load
as a
balance
The
standard
technology
SLAM
use
request
for
that
alongside
powers
this
all
HTML
these
DNS request to
prod modules
GC1,
is
and
called
build this
and so that particular
collective
client
learning.
starts getting served by
right?
this.
And
There
if you
are
think of all the
So,
other attempts to
this
add
is
other
a
libraries
relatively
in the browser,
simple way
First is
to get
Java,
multi-cluster.
It's a
so
short
the
form
goal here
for
is let's make it
availability,
enough
load
risk,
balancing pattern.
that anybody
signature,
can work on
Again,
this.
remember
And
here
let's make it general
we've
enough.
Think of it
designed
like a
such
CE
that
for availability.
Able to
The
applications
second
do not
is the knowledge
talk
graph.
anything
cluster.
from
They always go
In
north to
our
south
SIGDB,
or south to north.
we
to
store the
the
codified
bytecode languages
representation
like
of
Java,
all
.NET,
these
the
errors,
pattern.
failures,
Scripting
disruptions,
And
incidents,
I'm not going to
outages
go
that
through
have
this. You
happened.
can look at this later in
should
your
be
spare
able to
time.
execute
The second is
inside
knowledge
of
graph.
JavaScript.
So they
where
are
when a
essentially,
graph data
you can
structure,
always use an
by
external
far,
store
balance
that's the
the
appliance.
relationships
ambitious
of
thing
across
the
all of
WebAssembly
these
But that
thing
implies
do.
that
You add
that
on its
appliance
versions,
Not because of the
daily
technical
loads,
nuance,
so you have to
object
actually
considerations,
scale it
the
up
social
because it's
problem.
actually
So when you
some
move
traffic.
from one version to the other, you can traverse
you can have the
graph
second
on your
pattern, which is
specification
DNS
doing.
based global
So I've been
load balancing,
tracking over the years
where
how
can
many
tell you
you
what
don't
is
have to actually
incompatible
have an
with
appliance in the
So
data path.
Redmond
you don't
puts
have to
together
go
a
through that
simply
company
distributing
list.
different
have to
DNS
do
Almost
mappings
all
for
of
the
the
clients,
languages in
and
the
the
same
network
file
is
are in
doing
some
raw
stage
text
of
of
the actual
migration
data path.
over
So
to
it's
Now you
more
must be
scalable
wondering
that
where do
way.
we source this
The
information?
challenge
There
though
are
is that
three
as
sources.
I'm sure
outliers
most
right
The
of
now
first
you
one
know,
is we mine the
hosts
internet,
tend to
which
cache
is
DNS
GitHub issues,
solutions.
release
They
notes,
have
official documentation.
TTLs, which are usually
pull
quite
requests.
long. Sometimes
You are looking at this
does
information
work.
already. The
And
engineers are reading official documentation. What is
the Java
compatible?
community
What
is
is
the
end
only
of
one
life?
that sort of
You know,
resisted on
I'm
philosophical
running
grounds
into
that
this
they
issue
can't
right
there
now.
do
could
that.
be,
Someone reported that on
even though you would,
that's
in
all the
this
rest of
case,
them are moving
The second is
.NET
we
9
partner
comes
with
out,
Arrow
it's
vendors
fairly low.
because they
I
have
think
their own
the beta
support
drops
team.
within the
They
next
have their
couple
own
of
users.
you
So
could
one
have
of the
There are some
biggest,
trailblazers,
most
there are
established
someone
enterprise
who are
languages
following
has
them.
moved a
but
long
If
way.
someone
it's
has
not
seen a
having
problem,
a
why would you go
robust,
repeat the same mistake?
appliance
Python,
We become a
Ruby,
trusted
and
broker. The third is our users.
So I've got some
But,
sample
okay.
projects here as
One thing I
well
should point out
in
here,
the middle
We
column.
do not
So here's the
automatically
checklist
The
of things that were
third
necessary for the
pattern
cloud
is
format.
to
This
to
happens
use
all of
any
these
gas load
three.
A
balance
big chunk of the
service from a public
checklist that
cloud.
we were
These
looking
are
for is we
in
were
a
looking
sort
services
of
for
like
raw
a
AWS
server
Global
environment.
Accelerator,
into an internal
Because what we
mechanism
wanted
and
was
where
every
we have
cloud computer
check
engine has
users
to be
team.
run in a
and
secure
these are a little bit
sandbox.
expensive. They're really meant
Responsible
for
for
very
making
large
sure their
global
own
enterprise
firewall
institutions.
they curate these
But
services.
you can
Windows,
get
They have to
some
validate
really
them, they have to reproduce
high
them.
Ideally,
performance
you should be able to make
And
use
then
of
they
the
farm
cheapest
using
convert
those.
them to codified
They are
signatures.
expensive and they are on a per IP basis. So you're not actually
And
load
we
So we're
have
going
balancing
through this
tools like
checklist,
Watch
and this
Authority
lines up
providers to
really
scale
well
this
with what
literally load
WebAssembly was
balancing
already
IP.
On the
doing.
left side,
All we need to do
you
is
connect
take
with
the
your
WebAssembly
location
runtime,
to the
plug
other.
it
Kubernetes
into the
clusters
browser,
by giving you like
URL,
a
every
server
API
side,
listening
and
on that
build
IP
cloud
is
fine job that
effectively
collects
Turns
right
out
metadata.
we were not the
We
only
also
team
connect with
doing
the cloud
that. The
substrate.
But it
Alliance
is
just
actually
metadata from
what
the
you would want
organization
to do
working
for
on
a
the
very high
specifications and
enterprise.
send that metadata to our
And then finally, you can do
service.
your own
We began to
custom
run these engines
BGP
that
based
power all
NCAP.
these
now
You
is
can
Xeon.
literally
And they're
And then
building
we
a set
offer
of
you integration
specifications
for
that make it
tracking and
possible
reporting
to
purposes.
BGP-based CNI or something like MetalLB, advertise the same virtual IP from multiple clusters, and actually do this broadcast style on your own audience. You will need to have a BGP-based data center, and you'll need to know a little bit about BGP-based design with how it does the load balancing and so on. But you can build your own.
I'm going to take a pause here.
So these are a few different approaches. A few years ago, we had a blog which sort of
First
talked
tool
about
we
some of
built
these.
was called Spin.
This is another representation of sort of the cloud-based load balancer. Again, hopefully you can see that this virtual IP 201.210 is being advertised from different locations. And this is
and Radu said, we need a developer tool. What did Docker do to get successful? They built a tool that developers loved,
Google, that
and
kind of thing.
infrastructure teams appreciated the
Okay,
value
so
of,
the other
and
pattern,
instantly
key pattern
were
is
usually
east-west networking,
fighting
which,
wars
as shown in
over
this
who gets to
picture,
decide what technology.
is
You've got
when
two teams
services
agreeing on
are
what you
actually
wanna do.
split across
So we built
clusters.
Spin following
Earlier
that
we were
same kind
talking
of
about
It's a tool that was our core user story, the first
now
entire
not
first
talking
year
about
we worked on it
duplication. There may
was,
be duplication,
as a
but
user,
here,
I should be able to go
service,
from
here the
blinking
green service
cursor
has
to a deployed
two
application
replicas in
I did
cluster
not get
1
this.
and one replica in
This is
cluster 2.
first-hand insight.
Blue
goal
service
there was
has
to
three
say
replicas
this
in
is
cluster
really
1
great
and
for developers.
our customers
fall
would
in
come
love
to
with
us
this
and
tool
they would
because it's
say,
easy.
So that means if
Couple of
B4
commands,
goes down,
spin
then
new scaffolds on your
G3
project,
needs
spin
to be
build
able to
builds your
go
project
cross-cluster
using whatever
in order to
tool chain
access
you
the
need.
blue
So
service.
if you create a REST project, it'll
Um,
drop into Cargo. If you
Here
create a
again,
JavaScript project, it'll use
the
MVC
basic
and so on.
pattern would be
And
to
then
start start with single network, which means that the pods can directly talk across.
You'll also come up with some sort of knowledge-based article like a KBA will be the support team, which means if someone else comes in,
which means that the pods, you have to be careful with the pod siders, the host siders, they're all in the same routing domain.
These problems were in the layers owned by the clusters. Because there's
so now let's go back
so
real
many
quick.
of these
So we looked at
projects
the
require you to observe
are
namespace
managed.
This is a
which
spin
means
out
did an
that
amazing job.
written in JavaScript.
these kinds of
And
services,
then
Kind of see
the
in the
layers
tree
on
out
you
here.
have to have the
one
same
JavaScript file.
because
We
in
got
the same
package
exact
open
names,
source,
namespaces
free
in
node
all the
standards.
clusters.
and
Because
otherwise,
you know all your
you guys are
files are
experts.
back
You
and
run
all of
them
that
on
is
these
sort of
clusters.
scoped by your
Now, it's your
namespace and you
responsibility to make sure they all work together.
There
It's your
might be
responsibility
some
to tune
rare
them in a
cases
way
where
that
that's
they
extreme, but in
serve
most
your
cases
business
you
case or
have
internal
a
applications.
flexible
So
namespace management system.
that's where
in
I
enterprise
was
that
very
you can
painful.
do this
That
with
story of me
easy.
getting paged is actually
Look at
true.
and understand.
I've actually got
Hopefully
paged.
in a self-service manner.
At one time,
In any case,
decided I
assuming you
would
can do
test
that
this
and you have
against
this
AWS
single network
Lambda,
model,
because Lambda is, of course,
this is the
venerable
pattern here, right?
original serverless framework.
The next
so I created
pattern
an Amazon
is
account
east-west
and created a
multi-cluster,
and
but with
downloaded
multi-network.
Spin. And I timed myself going from
Here, you can see that these
beginning of the
pods
Hello World
are in network
documentation
1,
on Lambda
and
to
these
having
pods
it
here in the
deployed and
cluster 2 are in
routable to my
network 2,
application, and then did the
right?
same
So
thing
they
with
may
Spin.
actually have
Spin
overlapping
lived up to the
values.
2
They may
minutes thing, but
typically
it took
be
me
RFC
40 minutes, even though
1918,
I'm
like private
relatively well
Our
versus
biggest
cloud
source
technologies.
is the first.
So you
get my
can't
Lambda
really
function running.
directly
Where
discover a
okay, this
network.
is encouraged.
So you will use
This
these
is actually
gateways.
the smallest source.
Different projects use slightly different gateways, but fundamentally they're doing the same kind of thing. They're essentially natting.
Doesn't work.
Some of these projects require you to nat
I feel like contributing back. They
source
contribute
gateway
back.
and
So
destination
third wave
gateway.
of cloud computing, virtual machines,
Some others,
containers,
and depending on how you
where
do
do we
your
run our
host,
Some users
you can,
also
so
want
for
to be able to
example,
run it on bare metal.
the blue line here,
their own companies. So if you are part of a large
you know, one of the projects that we're going to talk about,
I don't want to share
one
these
we were
learnings
when
really
you're
with
going
anyone
across
else because
those
they're already
networks,
specific to my
likely will have to go through a
inside
gateway
of that
both at the
house,
source
which means
cluster
you have a
and at
private
the
instance of
destination
this.
And
cluster.
we
And
took
over
a couple
there,
Whereas the red
shots.
line
One
here
actually
shows
share
that
of
the
shared
pod
earnings
G3
within the
and tried
company.
running
able to
This
go
works
directly
very well,
out,
where you can say,
possibly
I have
from
these
the host
40 teams
It
right now, and
worked.
if 40
but
teams
it's
want
still
to
subject
want
to a
other
gateway.
CNCF, we
to
worked
do
on
the
it
same
for a
thing.
couple of years and then started
Now you
So
can
when
catch
you're looking at
actual
these
life
projects,
cycle
think
was
about
not gonna give us
exactly knowing how the data path works. So
started
you
sort
know
of
the implications
recategorizing
of
This is the biggest
how you
source.
run things in Kubernetes.
and
You know, you could run something
also
on top
sort
of
of
Kubernetes.
how to
In terms of
scale
add-ons,
that
we cover
gateway.
more than
You don't want the
200
gateway
You
to
can sort
become a
of
bottleneck.
fake
In
it.
some of
If you
these
don't have an
projects,
add-on,
the
you
gateway
can
can
do
actually
add-ons.
scale out to the
And
number of
deploy
nodes.
kubelets,
In some of the projects,
kubelet-like
you always have a
things that
primary
act like
gateway, and all the
kubelets,
traffic has to
but
go
are
through
their
that,
own little
which
beast.
means
And the
that
problem
becomes
with
a
that
bottleneck.
one ended up being
So,
that
but
all of the things that we
this is a
implemented there
pattern
were
that you want to think
detached
about
from the
when you're
rest of the
doing
Kubernetes system, like
multi-network.
the volume system.
Great
the
question.
So this is a busy
environment,
slide.
Chaos
I'll just
engineering
say
creates more work for you.
right now.
all of
If
the
you can take your
architecture
time to
for
go through
Kubernetes.
it,
You have
Well, that's
to
sort of a
shows
non-starter. That's really
go
not what we
and
set out to do.
types
is,
of
you know, build
solutions
a
that are
highly
frequently
complicated
used
they
to
have
do
layer
these
inside of
patterns that we
Kubernetes.
just talked about.
So the third way was to say, well,
the
what
first
if we just
category
run
is
it? What if we
what
just
you
go
can
down
do
to the
is
level of the
like these
container
are
runtime?
never
Kubernetes
have
CNI,
to,
which kind of do more than just CNI.
you know,
Right?
you
So
may never
now
run into
pods
it in
like
terms of
CDM,
production.
And
cluster,
the pod
mesh,
definition
and
The other
gets piped
problem
all the
is
way
you
down to
mentioned,
containerd.
let's say
One
they
say,
find
oh,
all these
well, if
problems.
this is a WebAssembly
Then there are the
binary,
service
Where do you
meshes,
find
right?
the
Things
fixes?
like STO, Linkerd, and so on.
You have to go back to the community.
Then
who's also
there's
understaffed.
advantage of
And you go to the
implementations
office,
of
all of the
multi-cluster
rest of
Kubernetes
Kubernetes,
very,
APIs.
you know,
your
special
like
case
WebAssembly
under
binary
these
looks
conditions,
exactly
Finally,
like
there's
the
condition
condition
happens.
virtual
And
application
for,
networking,
you know,
right?
all practical
Example
Like, yes,
being
this is
copper.
there, but no one has
These
seen it.
are
They may or may
more
not
like
fix it.
over-the-top
You are
networking.
relying
so you
on
use
not
volume
so
mounted
tied
Kubernetes.
to the
So it's a great
Kubernetes
tool for
infrastructure
finding,
itself.
service meshes and
But
all
these
that
are all
kind of
different
bounds
four
of a system
four
and
in
ways you
actuality,
can
instead of
do
running
But in
these
this
long
case,
running
we
server
just talked
processes,
about.
the known
you're just
failures,
running serverless
the
functions
known
that are
risks,
handling requests.
someone has run into it already.
I
And
will
so let's say you're running
highlight
Carpenter.
one of the points here. You can see that all of them support sort of single network, but when it gets to multi-network, there's some differences.
It becomes a big problem. It seems like you have run into such an issue.
Many of them require some level of elevated privileges
that's a known
because
issue.
you're doing
Why would
some
you
sort of
repeat the same
but the average Kubernetes node
configuration,
that's the big
except when
difference.
you've got a product
limits
that's
we actually reduce
space
like
like
telling you
Scupper over
what's
there.
going out there.
With WebAssembly, we can easily hit.
Some of them have more seamless
guidance is
network
coming from
policies
AWS, we
single
make sure
cluster mode and
if
multi-cluster
you
we
guys
work
mode.
wait.
around
The definition of
And
big
seamless
time
multi-cluster
we actually
services,
managed to
examples
try
being
out
Celium,
beautiful open source. You get
and
enough
even
users to
Istio.
go try it out and tell you things work, this is
With others, you have to have a completely different policy
we could
system.
just, orders of magnitude, again,
independent
more
of
dense than
Kubernetes
what
style
we could achieve there.
policies.
What kinds of use
So,
cases does that fit? Well,
keep these in mind.
So again, because you're allocating and deallocating,
and I've been asked this question before as well.
Each request coming
the
in,
way
right? So startup,
this technology is there today, right now,
so we talked about earlier that one of the issues with
a lot of different
DNS-based solutions is sort of that
I give a very simple
and so on.
When you
So
talk
now
to
you can
machines,
start
they give you
combining these
types
patterns.
of
the benefits.
So here is a
either they give you a
combination
best
of
rapid
answer
startup handle
or they give you the
saying,
exact
okay, I
answer.
want it to be really simple.
You're New York,
I
you're
want to
searching
originally
what's the
have
best
only
pizza
not
shop in New York.
but I'm having all these clients that are inconsistent
That's the best answer. It works for you. Because if you go there, chances are it's going to be really good.
So I'm going to augment it by saying that I'm going to
when
use
you're making mission
the
critical
DNS-based
you cannot rely on a best answer.
to choose
You have to have an exact answer.
to distribute my north-south traffic across clusters.
You cannot get an answer like,
But
yeah,
I'm
I
also
tried out,
going
it
to
may
use
work,
so that even if you end up going to the wrong cluster where you don't have
you need an
that
exact
service,
answer. Yes,
you
do
don't have
this.
the ability
You're
to
upgrading your
go
CSI
across
driver.
and
You just change the sequence.
So in this case, again, you're using
that's why the knowledge graph
more to augment
those
your
are the kind of use
north-south
cases that
plan.
WebAssembly
If your clients were fine, you could have done a much simpler solution by saying no east-west at all, because I'm just duplicating the entire application in multiple clusters.
Right now, we're in the business of exact answers.
But here you decide that, hey,
we are actually
this
not
is
okay giving you
consistent,
something which is
I want to make it more reliable. In this case, you can
you
spin
make
up.
a decision and come back once a day. You told us something, it would
So
work.
if you're doing something more
That'd be a problem.
DAPO-esque, where you might have a service that needs
Now,
to
it's
handle
also
a call
good
once
to,
every
so we
few
talked
dozen
about
requests,
patterns, right?
you can
So let's talk a little bit
drastically
more
cut
about
down
the
the
projects.
amount
We talked about these four
space that
categories
you
of
need,
projects, right? The CNI plus, the service meshes.
Memory and of CPU.
5 minutes.
So we
Okay.
released,
So
along
I
with
will
Microsoft,
actually
SUSE, Liquid Reply, and
skip
others,
through
we
some
released
stuff here.
SpinCube at KubeCon
I've got
this
content
year.
here which you can
So
take a look
SpinCube
later,
makes it
which
possible to
sort of
run
allows
spinning
you to
applications
appreciate how
inside
these
of
APIs are
Kubernetes.
evolving and
So
what
there's
are
a nice
some key
little
factors.
That's exactly the case where you have your internal
and
tooling.
they are slightly
Right now,
different
the way we
things.
have
For example,
the definition of
service
add-on is
meshes
something
and
which is in the
particular
open
ones
source
like
from a
Istio,
vendor cloud provider. It could have
So
one
that was
except
all
star. We would still consider
telling you a
that
story
an add-on.
as an
If you have
example
something
here,
in-house, which is
gateway
in
route
control,
and
we
the
call that
back
an
end is a
application.
service,
You can have
and
different labels for
it
those.
doesn't matter
You
whether
have
that's a
risks
back
that
end
you have
or
internally
single service
identified and you want to share it.
Kubernetes was sort of a stepping stone
So you can very
along the way.
seamlessly move. You can do this with regular Kubernetes. So here you have these things like service exports and imports, and you have to have different
the
deployment
same
manifests
capability of the
knowing whether
engine,
it's
so
single or
complicated.
multi-cluster.
And people were doing all their PhD work on it, but
Projects like
nobody had
something
something
in
in the
between.
shells.
They have the same resource, but you have to annotate it.
Kubernetes comes along, and a microservice design pattern comes along, and
So
suddenly
this again a
we're
bit of
just
eye
writing
chart, but I
distributed
think it will be
applications.
useful once you get time to look at it to see what's really going on,
But
and you'll
it
realize
should be
that
even
5
easier
minutes.
than
We have
it
5
is.
more
Right
minutes.
now, it's
API
incumbent on the
Kubernetes
developer teams to
is
build
sort
up
of
microservices.
picking up a
themselves.
lot
They
of the
pick
service
apart
mesh
the different
and
services.
multi-cluster type
They say this one's going to
functionalities.
do X, this one's going to do
And
Y, this
that's
one's going
why
to do Z.
many of these projects
And then
like
you
Istio
kind
are
of end
also
up with this case
supporting
where you're always
gateway
marshalling
API,
into JSON
and
and sending it
Right
across
now,
the
it's
Gateway
a
API
very
itself
lightweight cron
originally
job.
started as sort of
That
an
runs
English
on one of the
speaking
other
API.
agencies.
It was
They
just
will
for
maintain
north
all
south.
of those distributed code.
But
And
over time, it has had
and
its own
server,
mode,
efficiencies
right?
that you
Which
have
is
to
the
manage.
Dharma
You
project that
control
you
what
might have
exactly
heard
goes
about.
out. They give you filters
It has had
that any part of the
some
tree.
amount of
We've been working on
multi-cluster
for a few
support. You
years.
can
It's
put
just
service
finally now
imports
coming
as
to fruition.
backends.
February
So I
was
think
when the standards group
from
voted on
the
it.
Kubernetes
called-
native
it
space,
talks to the SaaS.
Gateway API will
but
continue
if you have
to
very
sort of
specific
try
But
to
essentially
be
what it
requirements,
a
those are
union
allows you
of
to take
both the gateway
two WebAssembly
functionality as well
binaries
as mesh functionality.
and say this
But I
binary
don't think
can use
these
this
are going to
interface to
converge
talk to this binary. These are the
immediately.
functions
For
that
a
can
while,
call. These are the
these
objects
projects
that
are
can
going to
pass,
have their own
pass back
APIs,
and forth. And when
and
you
they
do
will
that,
try to
suddenly you open up a very
some
new
extent,
world of the kinds of things you can
provide.
So let's say
they
you
are,
find a risk.
they are providers
You
for
have
the
to
other
fix
APIs
that
as well,
risk.
but they
So
will continue
think
to have
of a risk like a workflow, which means now you have n number of
which
affected
I think you
resources.
want to
all these
follow
things are
to
platform
see
neutral, very
what is the
fast
sort of
startup
future
and
path
user
of
friendly.
evolution of these
And so suddenly you
APIs.
can begin
now you assign
gloming together a
This
whole
was
bunch
again
of
going to be one
different
example of
libraries
how the
risks
gateway
as
API
part of the
differentiates
development
between
process,
gateway
which feels
mode and
exactly
mesh
like
mode.
usual
You assign assigned to the right owner.
I'll leave
You
that
can
thing
track their
to
progress.
later.
Someone
So the
say,
developer is how
this is by design.
sort of
I know about
uses
this risk.
annotation.
This is by design.
get
So
is
I'm gonna mark
tries
it.
to
Oh,
make
this is my
things
dev
look
test
very much
collection.
like
I'm not
Kubernetes
going to
API.
ignore it.
And those
Or
components
this is-
don't
so
necessarily
let's
I
wrap
recognize
up
this
with
risk, but I have a
guidelines.
workaround right now for 3 months,
Couple of
which means
minutes
give me an
here.
extension for 3
how
months.
it's going to manage
All of those
that.
workflows
So
are
you've
native,
unlocked a
which
couple
means
of different
anything
things
that you
with
see
the
So final
here,
set of
which is going to
recommendations
you,
is
you've
do
unlocked this
start
as a
with
workflow
a
where you
multi-cluster
can
design.
develop action
sits in their
items,
comfort
It is a
zone and is
decade,
building
but
distributed
start very
people.
simple.
The second one is
no need to
you
jump
can
ahead.
actually
you know,
created a
You
really
can
good
think ahead.
change the
You
severity.
don't need to execute ahead.
You will get all of
take a
those
library
because at the
written
end
in
of the
Rust,
day,
a library
there's
written in
this
you may
Python,
have some
compiled
additional
along
Common by
with
column
it,
hacks,
in and out
which
of
is
each of those
no
with
is
your
temporary.
JavaScript
You can always say
with
no
your
complexity
.NET
initially.
in
You can
certain
always change
cases,
that
you unlocked
later.
polygon
But once you
programming, which is
allow a
really the
complexity,
You have. That's what I'm
it's
talking
down.
about. That's what I'm
So think about that.
And the third one is, if you're running each one in its own little security
some rules of
sandbox,
thumbs are prioritize
you can
the
start
north-south
making security
multi-cluster.
assertions
Many things
not
you
at the
can get done
application level,
just by simply
but at the
having
component
separate
level
independent
and say,
clusters.
hey, this
no
component that I
coupling between
downloaded
them,
off the
but
internet
just
is
have
supposed to
north-south
use part
clusters.
YAML.
You're getting
It's
the
not allowing
benefits
access to network,
and you're not having
anything other than what I
cross-cluster
pass into it.
dependencies. You don't
This
have
thing
one
here,
cluster
this
has to
developer
have the
team
cube
built,
configured.
whatever
they
the
need file
fix
system
is,
access, we
in
grant
order
the
to get
watch.
a
This thing has
remediation.
PII
You have
information,
to
none of
start
that data
talking
ever
about
goes out
lots
of
of
context.
credential
Start
management,
laying
remediation
on
management.
The fix is not
security
available.
parameters.
This
Actually,
is a
you
bit,
don't
I
need
was
this
showing this
fix.
some
Now,
right
there's
now.
no
There are
tool in
obviously
node
plenty of
leakage right
cases
now.
of
This is
prioritize
the
a single
version
network mode.
And this,
Less
I
than
think, is
version
going
one.
Try to
change
stick
the
with
way
single
we
network
can
mode if
make
you can.
with the
about
activity
security
nodes,
It's better
these
for
releases don't
And
get
I'm not
something
saying
targeted.
daily
anything
would
else
work,
about that,
like
because you're sitting
stateful
there
workloads
If
cannot
you
work
work
if you have
mode, which you eventually
You're
have
probably
to
already
have,
hacking this in your mind.
it's
if you
a
didn't
ticking
see the
time bomb.
previous
If you're
demo.
having issues with
So,
IP addresses, leverage
fix is not
VPCs
there, but the
and
remediation is
leverage
there right now,
IPv6.
which means
I
you
think
can
this
go
is
and write
a
a
good
job
reason
which can
to
clean it up
actually
every
go
24 hours,
more
or 1 week or 1
IPv6 so that
month
you can
based on
begin
But
and
the
start
component model is
tracking
the other
that
thing that I'm
We
really
will give you
excited
both
about.
of
So we've
those.
got kind of this
Yes,
three ways
there
to
are
cloud
cases where you will
communicate
need
virtual
the
machines and
fully
containers, and now this
full featured multi-cluster solutions,
style
and the
runtime
tools do
with
exist,
WebAssembly,
and they're getting
then this
better all the
component
time.
model that allows us to start to build
And
sort of
here
the
I have
next
sort of
generation of
a
distributed.
different way
how
of
much does
having
it
3
cost?
levels of
There's a QR
multi-cluster
code that will get you started with
Talk to us
Spin.
after.
If you'd
a
like to
level
take
level
Spin
1
for a
is sort of
spin.
minimize your intercluster dependency.
And also,
I think
we
we
have
have 2 more minutes.
Southbound
Any other
balancing,
questions? If not, we have a booth upstairs.
hang out there.
There's going to be happy hour as well. You can
Level
drop
2
by, ask us
is
questions.
have some
we'll be happy
basic
to dive
Thank you all
in.
very much. Appreciate it.
And
Prefer
also,
having
more
single
than happy to
network.
set up a follow-up.
If you're running out of addresses, definitely consider IPv6 and maybe do some simple
talk.
multi-mesh to either augment your north-south or for certain use
Awesome.
cases. You
Great.
should.
Thank you, folks.
And then if you are an advanced user, then yes, you do want to look at level 3, which includes multi-network, multi-organization,
So we have 10
where you can
minutes
actually
break, and then 12:20 we'll have another session before lunch.
trust
So I will
domains
see
for,
you soon. Thank you.
certification. And there's a lot of implications for high-scale design, which don't matter when you're doing 2 or 5
and in
clusters
fact,
in a
the
multi-cluster
component model is built
versus when
as
you're
part of the
doing 200
WebAssembly
or 500
specification of the
clusters.
WASI specification, the
There's a whole
system
new ball
interface
game in
style,
terms of how you're
which
managing
means
your
that,
kube configs and
VS Code
so on.
introduced
And
the
you know,
ability to run
like
components
for example,
natively
there's this project
inside
called
of their
KD Store
extension
Mesh,
mechanism
which is
last
used
week.
to increase Cilium's
And
scale when you're going to that
F5
scale.
introduced the
So
ability
think about
to run
these levels,
components inside of NGX
and not all
unit
of these
a couple
fall
of
into
months
these
ago,
levels.
and so
Projects
it
like
is quickly
Scupper,
becoming the kind of
because
thing that
they're
will
in
be
user
standardized.
space, they
And
don't
that's
even
really good. Right,
they don't
because
even
why
exactly
is
fall
NPM
into that. So
successful?
that's
Because
another
lots
option
and
when
lots
you
of
want to
people can use
do
it.
sort of a
why is
user
cargo
space
and crate
solution.
successful? Because
And
lots
that
and lots of
actually
people
works
can
very
use
well.
it. So what we want isn't necessarily only Spin.
Okay,
being
I was going to do a demo in which I was going to show that if you're doing just the north-south load balancing and you want to keep it simple, you could still have some reliability issues, right? So we talked about the DNS cache issue and so on, right? Another issue is that all of these.
Any other questions?
Okay. Okay, so we're done. So we had a bit
Thank
of
you again.
a delay at the start, but you've got some material here to look
sorry,
over.
yeah.
And feel free to contact me, and good luck with your multi-cluster deployments.
Thanks for your patience.
Yeah.
So that is a great question. So isolates from Cloudflare is a way to run JavaScript within a VM, within a V8 instance. Cloudflare
Up next is Lucas Gentile, CEO at Loft Labs, about multi-tenancy.
You know, I wouldn't be the person to be able to explain the details of Cloudflare's security model to you. The WebAssembly security model is kind of built on a different premise than Cloudflare's. But execution style, you get sort of a similar goal in that you should be able to execute a serverless function as quickly as possible and free up resources. But the implementation with WebAssembly is to say we're going to give you strong isolation into this bytecode format that'll be able to run any language. Again, the component model is different. But I would say of all the other serverless implementations that I've ever seen, Cloudflare's workers are the other one that I think is remarkably fast and resilient. So you can think about those two as being in you know, sort of the abstracty way in competition with each other. Again, the nice thing about WebAssembly is by default you can run anything from C to Python and Rust and everything but Java inside of the runtime. And I dismiss Java, but actually there are a number of community efforts to get WebAssembly Java support. So it too is coming along. It's just coming along at a slower pace and without without necessarily Oracle's endorsement at this point. Any others?
Product engineering, future products. Yeah.
All right, thank you all
Of
very
course,
much.
in this case, we already have many existing products, but we are continuing to. Do you use any Red Hat products?
I'll shut this.
Yeah. Hmm. I know. Okay. RKE2. RKE2. Okay, take a look at that. What is your biggest concern with multi-cluster? Mm-hmm.
It's this one. Okay.
Cool. What is it? It's 1?
Yeah, it's room 1.
You're active, so.
Good.
Finally what? Yeah, okay. Are you working with together? Oh, different. Okay.
Yeah, it's kind of nice, but I'm sort of bored of it. I'm applying for other
Yeah, Raleigh. Yeah. You're also from Raleigh? Huh? Yeah. You also. All three of us are from Raleigh.
for a little
Yeah.
while, especially since I really moved into the
Sure.
developer.
Yeah.
Wow, the dev realm.
Raleigh IT. I don't. I mean, there are other Red Hat groups that do it. Yeah. I'm not. In
Yeah,
that.
it's been enjoyable. I some pretty popular projects.
Yeah.
The health project.
Sure.
Is like
Yeah. And I would like to learn what you see in the different customers and what are the different priorities and problems. Yeah. Mm-hmm.
1, 2.
Yeah.
Absolutely. Do you know
Sure. Yeah.
is in your organization as well? He focuses on Tanzu. He and I used to work together at Network.
Yeah.
He's a big hacker. He supports brilliant. He was on the developer experience team. So
Okay.
Yeah. Where are you originally from?
India. Yeah. Egypt. Okay.
I was just there last year in the G. I went to the G20. Yeah.
Okay. Okay. Huh? Gurgaon. Yeah. Near Delhi.
Anything in terms of
So, what was your experience?
Clicker works, I assume.
Yeah.
Was that your first time? Yeah.
The last speaker was there was some trouble with it.
Okay.
But I believe that was because the slides were updated, added very late. So
Oh,
they didn't
same
have
here
them.
though.
Really? Let me double check this and make sure that you're
It's
good.
getting better. Yeah.
You want to go off slides, not
Yeah, maybe
PDF
they
versus
took you on the
PDF
good road. They don't show you the bad
Slides
road.
would be fine.
Because
PDF
these
is
are our
fine
guests.
too,
I have to show them the good ones.
Great. Well, I'll just triple check that then for you.
Okay,
Yeah.
thank you.
Yeah. So are you also from Egypt or?
Is this on?
Nope. Yeah.
some water or anything?
I put some water over there.
Hello, hello? Yeah.
We're going to start in just a minute. Do you feel ready and everything?
I'm good.
Awesome. Okay, let's go. Do you pronounce your name Lucas Gentili?
Yeah.
Okay. Great.
All right, thank you.
All right, everyone. We are starting on time for the first time on track one. I'm Scott Rigby. If you hadn't seen me before, I co-organize the regular New York City Kubernetes meetups and CNCF meetup stuff, and I'm just co-chairing track one. So. I want to introduce Lucas Gentili, who is the CEO at Loft Labs, if you've ever heard of that awesome company. And he's going to be talking about multi-tenancy and the different options therein. So just let me know if you need anything, and just take it away.
Awesome, thank you.
Maybe.
Yeah. Hey everyone, good to be here. We're talking about multi-tenancy and how to isolate tenants, but also how to ensure tenant autonomy. You probably have not heard of Loft Labs. You've rather heard of vCluster, which is the project that we started in 2021. It's gotten pretty popular. A lot of
nervous with this many
companies are
people
using
here.
it.
Now I have this
we just
pressure. This
announced
should be a good
our
talk.